Welcome to our channel. Tonight, we'll share space facts to fall asleep, calm stories from the universe to quiet the mind and gently guide you into rest. From interesting facts about space to mysteries that stretch across time, this journey blends science with stillness. These are not just stories, they're quiet explorations, perhaps even boring facts, to put you to sleep as you drift beyond the stars. Let's begin. The galaxy without any dark matter. In the vast darkness between stars, there exists a mystery that has puzzled astronomers for decades. Dark matter, the invisible substance that doesn't emit light or energy, but still seems to shape galaxies, bend light, and hold everything together. Or does it? In 2018, scientists discovered something that shook our understanding of the cosmos. A galaxy named ANGC 1052-DF2 appeared to contain no dark matter at all. That's like finding a house with no foundation, yet it's still standing. Most galaxies are surrounded by massive halos of dark matter, unseen but necessary to explain how they rotate and form. Without it, the visible matter alone simply isn't enough to keep a galaxy from flying apart. But this one, it rotates slowly, spreads its stars loosely, and seems to hold itself together without any hidden mass. For a while, some scientists believed it was an error, a trick of distance or light. But later observations, including data from the Hubble Space Telescope, confirmed it. The galaxy truly lacks dark matter. This strange discovery has opened up new space theories. Could dark matter be more complex than we think? Could there be other forces at play? Or maybe, just maybe, dark matter isn't as universal as we believed. These are the kinds of mysterious facts about space that leave scientists both baffled and excited. For every law we think we understand, the universe offers exceptions, whispers of unknown rules still waiting to be uncovered. And as you lie still tonight, floating through thought and silence, imagine drifting near such a ghostly galaxy. Its stars spread thin, its movement slow, its structure held together, not by force, but by quiet wonder. A place that breaks the rules, and yet still exists. Let's continue deeper into the unknown, where more cosmic questions wait in the dark. The planet that orbits in just 18 hours. Imagine a year that lasts less than a single Earth day. In the depths of space, some worlds move so quickly they seem to race around their stars, locked in orbits that defy everything we know about planetary motion. One such planet is known as Kepler 78b, a rocky exoplanet that completes a full orbit around its star in just 18 hours. That means from one sunrise to the next, its entire year passes in less than a day, not a season, not a month. A year done in less than one night's sleep. Kepler 78b is incredibly close to its parent star, so close in fact that its surface temperatures soar to more than 3,000 degrees Fahrenheit, or about 1,650 degrees Celsius. That's hot enough to melt rock, vaporize metal, and strip an atmosphere bare. Scientists believe that parts of its surface may be covered in lava oceans, with molten rock flowing like water. It's a place where time and heat twist everything into a state of chaos. And because it's so close to its star, the planet is likely tidally locked, meaning one side always faces the star, scorched in eternal daylight, while the other side remains in endless darkness. We've found dozens of such worlds now, called ultra-short period planets, and each one offers a glimpse into the extremes of planetary science. These aren't just interesting facts about space, they're mysteries, reminders of how strange and varied our universe truly is. For those who love space facts to fall asleep to, there's something poetic in imagining a planet that races through time, its days and years blurred together, bathed in fire and shadow, a world in constant motion, a silent orbit on fast forward. And so we drift again into the next mystery waiting in the stars. Signs of life on Enceladus, far beyond Earth, orbiting the giant planet Saturn, lies a small moon cloaked in ice, quiet, reflective, and at first glance, unremarkable. But beneath that icy shell, Enceladus hides something extraordinary. In 2005, NASA's Cassini spacecraft discovered towering plumes of water vapor erupting from its surface, shooting hundreds of kilometers into space. These aren't just clouds of steam, they're rich in salts, organic molecules, and heat. Signs that deep beneath the crust, there may be a vast subsurface ocean warmed by the slow, invisible pull of Saturn's gravity. That ocean may be one of the most promising places to find life beyond Earth. Even though there's no sunlight under the ice, life doesn't always need light. On Earth, deep in the oceans, entire ecosystems thrive around volcanic vents, surviving on heat and chemistry, not sunshine. Enceladus might offer something similar, a dark, protected ocean with the right ingredients and the right conditions. Scientists across the world are fascinated by this tiny moon. One such group is called SETI, the Search for Extraterrestrial Intelligence. It's an institute that studies the universe for signs of life beyond our planet. Their quiet work follows clues like Enceladus's plumes, building a larger picture of what's possible in the cosmos. We don't yet know if anything swims beneath that frozen shell, but the mystery is enough to make Enceladus one of the most watched places in the solar system. So as you settle deeper into sleep, let your thoughts drift beneath layers of ice into a quiet sea, hidden in the dark. A sea that may be home to something alive. One moon, one ocean, one of the most intriguing space facts to fall asleep with. Let's continue. The invisible web that connects the universe. Look up at the night sky, and what do you see? Stars, maybe. A few distant galaxies. A patch of darkness speckled with light. But beyond what our eyes can detect, the universe hides something far more intricate. A giant cosmic web. This web isn't made of silk or string. It's made of dark matter, gas, gravity, and galaxies, all woven together into a vast, interconnected structure. Scientists call it the cosmic web, the largest pattern in the known universe. Imagine this: billions of galaxies aren't scattered randomly. Instead, they're strung along enormous filaments, like pearls on invisible threads. These filaments stretch across millions of light years, connecting clusters of galaxies like bridges between cosmic cities. Between them lie vast voids, empty spaces so immense and dark they make galaxies look like islands in a quiet sea. We can't see this web directly with our eyes, but we observe it through light, how it bends, travels, and shifts as it passes near massive structures. Using tools like the James Webb Space Telescope and the Hubble, scientists map these invisible threads, revealing the skeleton of the universe itself. And what holds it all together? Gravity, time, dark matter, a silent architecture sculpted by invisible forces. It's one of the most science-defying and mysterious facts about space, that the entire cosmos is organized not in chaos, but in quiet, delicate balance. So as you drift into sleep tonight, imagine yourself floating between those threads, weightless, quiet, slowly pulled along the strands of time, like a traveler gliding through a forgotten corridor of stars, guided by the invisible design of the universe. Let's follow that thread to what comes next in the great cosmic story. The faint glow from the beginning of time, long before stars were born, before galaxies took shape, there was only darkness, and then light. Not a flash, not an explosion, but a quiet spreading of energy, the birth of the universe itself. Over 13.8 billion years ago, the universe was just a hot, dense cloud of energy and particles. Then, in an event we call the Big Bang, it began to expand rapidly, endlessly, forming time, space, and everything we know. But here's what makes this story so extraordinary. The light from that moment never truly disappeared. It's still out there, all around us, moving through space like a whisper from the past. Scientists call it the cosmic microwave background radiation, or simply the oldest light in the universe. We can't see it with our eyes. It's stretched thin and cool, just a faint hum of energy. But sensitive instruments like those aboard the Planck satellite can detect it. They map this radiation like a faded photograph, a soft, speckled glow that fills the entire sky. This light has traveled billions of years to reach us. It's a space theory made real, a science fact from the edge of time. It tells us how the universe began, how it cooled, expanded, and formed the structure we see today, an echo from the beginning. So as you rest tonight, imagine that quiet glow passing through you, gentle, ancient, calm, a relaxing reminder that we are part of something far older than ourselves, and yet still connected to it by light. Now, close your eyes and let's follow that ancient beam toward our next journey through the cosmos. The hidden giant, with rings 200 times wider than Saturn's. When we think of planetary rings, one name usually comes to mind: Saturn. Its icy loops are iconic, stretching gracefully around the planet like nature's most elegant jewelry. But somewhere far beyond, orbiting a distant star, there's a world with rings so massive they make Saturns look like toy hula hoops. Meet J1407b, a giant exoplanet, or possibly a brown dwarf, located about 400 light years from Earth. It's sometimes nicknamed the Super Saturn because of its incredible ring system, which is estimated to be 200 times wider than Saturn's. If placed in our solar system, its rings would span across the sky, easily visible from Earth, glowing like a full moon. Imagine lying under a night sky where rings stretch from horizon to horizon, softly glowing with reflected starlight, a quiet dance of ice and dust. Astronomers discovered these rings not through pictures, but through patterns of light, watching how a distant star dimmed and brightened as J1407b passed in front of it. The complex flickering revealed the shadow of something enormous, layered and circular. Some scientists believe that these rings may one day form moons, slowly coalescing from dust and rock, much like how our own moon might have formed. It's a space fact to fall asleep to, but also one to dream about. A giant planet with a crown of rings so wide, so beautiful, they could reshape how we imagine the night sky. There are so many interesting and mysterious facts about space, and this one reminds us how small and how lucky we are. So take a breath, let your mind drift toward the edge of possibility, and picture a sky filled not with stars, but with rings. Let's glide onward toward our next celestial discovery. Twin galaxies that mirror each other across the universe. Somewhere in the deep black of space, beyond what the naked eye can see, there are galaxies, entire cities of stars that appear to mirror each other perfectly, not just in shape, but in glow, rotation, even structure. Scientists have spotted these cosmic twins, galaxies so alike, it's as if they're looking into a giant mirror suspended across the universe. They're called interacting galaxy pairs, and one of the most famous examples is ANGC 4676, often nicknamed the Mice Galaxies. These galaxies are currently in the middle of a slow-motion dance, pulled toward one another by gravity, stretching out long, delicate tails of stars and gas behind them. Though they're millions of light years apart, the symmetry between them is stunning, a moment frozen in time, as if the cosmos paused to admire its own design. This strange harmony isn't random. It's the result of gravitational interaction, a tug of war over eons that molds these galaxies into matching forms. It's one of those mysterious facts about space that makes us wonder what else out there reflects itself across the void. So tonight, as your thoughts begin to settle, imagine drifting quietly between two galactic mirrors, watching them spiral, shimmer, and stretch. A space story to fall asleep to, wrapped in symmetry, light, and stillness. And as you float between reflections, let your mind follow the curve of starlight into our next cosmic mystery. When stars disappear without a trace, imagine gazing into the night sky, and one night a star is simply gone, not faded, not exploded, just vanished. This isn't science fiction. Astronomers have recorded real cases where stars, massive, ancient, and once bright, have seemingly disappeared without any trace. In one instance, scientists observed a giant star 25 times more massive than the Sun, and then in 2009, it was no longer there. There was no supernova, no dramatic collapse, just silence. One theory suggests it may have collapsed directly into a black hole, skipping the explosive finale we usually associate with dying stars. Another proposes that a dense cloud of dust may have hidden the light, or maybe the universe is whispering secrets we haven't learned to decode yet. It's one of those space theories to fall asleep to, an interesting fact about the universe that humbles us. In the cosmic scale, even stars, giants of fire and fusion, can vanish like a dream fading at dawn. So as you rest tonight, let this mystery settle gently in your thoughts. Not everything needs an answer. Some stories are meant to be observed, to be wondered about like a bedtime story for grown-ups, told by the stars. And now, with that wonder still in your heart, let's drift onward into another secret space holds close. The universe has a voice. We just can't hear it. They say space is silent, but silence doesn't mean the absence of sound, only the absence of air to carry it. And yet, the universe does make music. It hums, it pulses, it sings through waves and vibrations that we can't hear with ears, but we can feel with instruments. NASA has recorded the sounds of space by converting radio waves and plasma frequencies into audible tones. The result is haunting. Deep rumbles, distant moans, eerie melodies from places like Jupiter's magnetosphere or the solar winds hitting Saturn's rings. They call this space sonification, a way of listening to what stars, planets, and black holes are saying. It's not music in the traditional sense, but it's rhythmic, beautiful, and deeply relaxing. A reminder that even in apparent stillness, the universe is in motion and in song. So as you prepare for sleep tonight, imagine yourself floating in that cosmic quiet, surrounded by the low vibrations of stars, as if the universe were humming a lullaby just for you. It's not noise. It's not silence. It's something deeper, a cosmic ASMR, a soundtrack made of space and time. Let this final fact be a gentle farewell for tonight. Let the universe sing you to sleep, and tomorrow we'll drift even farther. We've traveled far tonight, through galaxies, collisions, oceans beneath ice, and echoes from the birth of everything. Now, as we approach the final stop on this journey, let's peer into one of the strangest objects the universe has ever made. Looking into space means looking into the past. Every time you gaze at the stars, you're not just looking far away, you're looking back in time. This might sound like fantasy, but it's one of the most fascinating science facts we know. Light doesn't travel instantly. It has a speed about 300,000 kilometers per second. So when light leaves a star, it takes time to reach our eyes. If a star is 100 light years away, you're seeing it as it looked 100 years ago. If it's 1,000,000 light years away, you're witnessing a 1,000,000-year-old image in real time. When we observe distant galaxies, we are looking at the ancient snapshots, cosmic photographs frozen in light, some from before Earth even formed. In fact, the James Webb Space Telescope was built for this exact purpose, to see deeper into the past than we ever have before. And it's working. We've captured light from galaxies born just a few 100 million years after the Big Bang, the earliest light we can see. So tonight, as you close your eyes, imagine drifting through space, watching starlight pass by your fingertips, each beam a whisper from long ago. The cosmos doesn't just stretch across space, it stretches across time, quietly telling stories from billions of years ago. And as your mind begins to quiet, let this fact settle in. You're part of that story too. Now, let's drift gently into one final discovery for the night. What the James Webb Telescope has already changed. The James Webb Space Telescope is the most powerful observatory ever launched into space. Its massive gold-coated mirror spans over 6.5 meters, more than twice the size of Hubble's, allowing it to collect faint light from the farthest corners of the universe. Webb operates mainly in the infrared spectrum. This gives it the ability to peer through cosmic dust and observe ancient galaxies whose light has been traveling for over 13 billion years. In just its first year, Webb has captured the most detailed images of the early universe ever seen, showing galaxies as they looked only a few 100 million years after the Big Bang. Its instruments are so precise they can detect the composition of distant exoplanet atmospheres. Webb has already studied planets like K2-18b, identifying water vapor, carbon dioxide, and even potential signs of organic molecules, raising the possibility of life beyond Earth. Unlike earlier telescopes, Webb is positioned nearly 1.5 million kilometers from Earth at a point called L2, where it remains shielded from the sun by a 5-layer sun shield the size of a tennis court. This isolation and cooling system allow it to detect even the faintest heat signatures from distant celestial objects. From revealing the structure of early galaxies to analyzing atmospheres light years away, James Webb has transformed how we explore the universe, not just by seeing deeper into space, but by looking further back in time than ever before. As you rest tonight, remember, while the world sleeps, Webb is still watching, opening new windows into the unknown. The secret ocean beneath the ice of Enceladus. Let's drift now to one of the coldest, most mysterious corners of our solar system, the tiny moon Enceladus, orbiting the gas giant Saturn. At first glance, Enceladus looks like just another icy satellite, a smooth white sphere covered in frozen ridges and cracks. But it hides a remarkable secret. Beneath that frozen shell, there is an ocean, a real ocean. Liquid water, trapped below miles of ice, warmed not by sunlight but by the tug and pull of Saturn's gravity. This push and pull creates heat through friction deep inside Enceladus, keeping its underground sea from freezing solid. But how do we know it's there? In 2005, the Cassini spacecraft flew by Enceladus and saw something extraordinary: plumes of water vapor, ice crystals, and organic molecules erupting like geysers from the moon's south pole. These jets shoot into space from long, dark fractures called tiger stripes. and scientists realized they were coming from a vast, hidden ocean beneath the ice. That changes everything, because where there's liquid water, there's a chance, just a chance, that life could exist. Not life as we know it, perhaps, but microbial life, clinging to warmth and energy in that alien sea. Some scientists even believe Enceladus may be one of the most promising places to search for life beyond Earth. It's strange to think that one of the best places to look for extraterrestrial life isn't a distant exoplanet, but a small moon right here in our own backyard. Imagine floating under that ice, in complete darkness, surrounded by the quiet hum of a subsurface sea. No sky, no stars, just stillness, warmth, and maybe life. These are the kinds of stories space tells us. Silent, hidden, waiting to be discovered. Let's keep drifting. Next, we'll listen to the ancient echoes left behind by the birth of the universe itself. The echoes of the Big Bang are still around us. Imagine the universe before anything we know existed. No stars, no galaxies, no planets, just silence. And then in a single instant, everything changed. The Big Bang, a moment of unimaginable energy, burst forth, creating space, time, matter, and the blueprint for everything that would follow. But here's what's extraordinary. The echoes of that moment are still with us. All around us, in every direction, there's a faint glow, a soft, invisible hum that fills the cosmos. Scientists call it the cosmic microwave background, or CMB. It's not sound in the traditional sense, but a remnant of radiation from the Big Bang itself, now cooled and stretched over billions of years as the universe expanded. It's been traveling through the cosmos for 13.8 billion years, a soft afterglow of creation. This ancient light was first discovered accidentally in 1965 by two radio astronomers, Arno Penzias and Robert Wilson, who thought at first they were picking up interference, perhaps from bird droppings on the antenna. But what they'd found was something far more profound, the whisper of the universe's beginning. You can't see the CMB with your eyes, but with the right instruments, like those aboard the Planck satellite, we've mapped it across the entire sky. And what we see is astonishing, a nearly uniform glow, dotted with slight temperature variations, just a few millionths of a degree different from point to point. These tiny fluctuations are what eventually gave rise to stars, galaxies, and everything else. In a way, every moment of your life takes place inside the echo chamber of the Big Bang. It's humbling to think that even now, as you lie in bed, drifting towards sleep, you are surrounded by the afterglow of the universe's birth. You are listening in silence to a story that began before time had meaning. And with that thought, we drift to the next chapter. Why the moon is slowly leaving us. Look up at the moon, serene, steady, familiar. It's been with us since Earth's earliest days, lighting our nights, shaping our tides. But what if I told you it's drifting away? Every year, the moon moves roughly 3.8 centimeters farther from Earth. It's a tiny shift, no more than the width of your fingernail, but over millions of years, it adds up. Scientists discovered this using laser reflectors left on the lunar surface by Apollo astronauts. By bouncing lasers off those mirrors, we've been able to measure the distance with remarkable precision. Why is the moon escaping us? The answer lies in tides. Earth's gravity pulls on the moon, but the moon also pulls on Earth, creating tides in our oceans. These tides, in turn, create friction, and that friction transfers a bit of Earth's rotational energy to the moon. As a result, Earth spins a bit slower, and the moon gains a little push outward. In the far future, this cosmic tug-of-war could have profound effects. Tides will weaken, days on Earth will grow longer, and the moon will appear smaller in the sky. One day, a total solar eclipse, that perfect alignment of sun, moon, and Earth, may no longer be possible. It's a quiet reminder that even the most stable things in our lives are slowly changing. And yet, this slow dance between Earth and moon continues silently above our heads. Now let's keep floating through space. The next fact is waiting. Mars used to look like Earth. Once upon a time, billions of years ago, Mars may have looked strangely familiar. Imagine vast oceans, winding riverbeds, rain clouds drifting over dusty plains, not unlike the early Earth. Scientists believe that Mars once had a much thicker atmosphere, capable of supporting liquid water on its surface. Evidence of this watery past is etched into the landscape. Deep canyons carved by ancient rivers, lake beds long dried, and minerals that only form in the presence of water. The Mars rovers, like Curiosity and Perseverance, have helped uncover this hidden history, revealing layer after layer of sediment that tells a story of a planet that may have once been warm, wet, and possibly even habitable. But something changed. Over millions of years, Mars lost much of its atmosphere, likely stripped away by solar winds, as the planet lacks a global magnetic field to protect it. Without that shield, the once vibrant Martian climate collapsed. The water evaporated or froze. The skies cleared, and what remained was the cold, red desert we see today. Still, the mystery lingers. Could life have existed there, even for a brief time? Could signs of it remain buried in the Martian soil? As we continue to explore, Mars reminds us of how delicate a planet's balance can be, and how similar our worlds might once have been. Ready for another journey? Let's drift now into the next cosmic secret. A planet made entirely of clouds and storms. Imagine a world with no solid ground, no mountains, no soil, not even a place to stand, just endless sky, winds that never rest, and storms that rage for centuries. Welcome to the gas giants, Uranus and Neptune, planets made almost entirely of clouds and storms. Let's focus on Neptune, the most distant planet in our solar system. Beneath its calm blue exterior lies a violent atmosphere where winds can whip across the planet at more than 1,200 miles per hour, faster than the speed of sound. These are the fastest winds recorded on any planet. Neptune is a world of ice and gas, with swirling storms that dwarf anything found on Earth. The Great Dark Spot, discovered by Voyager 2 in 1989, was a storm roughly the size of our planet. And though that specific storm has since disappeared, new ones have continued to form, appearing and vanishing like ghostly cyclones in the deep. Uranus, too, is a planet of clouds, but with its own peculiar traits. It's tilted so dramatically that its poles almost point directly at the sun during parts of its orbit. This creates bizarre seasons that last decades, entire hemispheres plunged into darkness or bathed in sunlight for years at a time. These planets are made of hydrogen, helium, and ices like water, methane, and ammonia. But beneath those thick atmospheres may lie strange, slushy oceans, not of water, but of exotic substances under extreme pressure. You wouldn't survive long here. There's no surface to land on, no solid ground to set foot, just thick clouds, intense cold, and unrelenting storms. Yet even in these chaotic conditions, there's order, layers, patterns, cycles that scientists are still working to understand. So next time you look up at the night sky, remember, not every planet has a surface. Some are made entirely of sky, wind, and mystery. And with that, let's continue our journey across the stars. Rogue planets floating alone in the dark. Imagine a world without a sunrise, no warm light, no orbit around a star, just endless night. That's the reality of rogue planets, mysterious celestial bodies drifting through space completely untethered from any solar system. They don't orbit a star. Instead, they float freely in the vast darkness between systems like cosmic wanderers with no home. Astronomers estimate there could be billions of these rogue planets in our galaxy alone, possibly even outnumbering the stars themselves. Some were likely ejected from their solar systems by gravitational forces in their early history. Others may have formed in isolation, never bound to a star in the first place. Whatever their origins, they now travel through the interstellar void, silent and cold, illuminated only by starlight they'll never orbit. Without a sun to warm them, these planets are thought to be incredibly cold, perhaps with thick atmospheres trapping whatever little heat remains deep within. And yet, some theories suggest that subsurface oceans might still exist beneath insulating layers of ice, kept warm by internal geothermal energy, just like the icy moons of Jupiter and Saturn. Could such worlds harbor life? It's a haunting thought. Entire hidden ecosystems floating in total darkness, unknown, untouched, unseen. These rogue planets remind us that not all planets belong. Some are loners, drifting quietly through space, far from the light, and perhaps far from our imagination, until now. Let's drift onward. The next fact takes us to a moment where galaxies collide and something extraordinary is born. The Great Attractor, something is pulling our galaxy. There's a force in the universe pulling us, pulling the entire Milky Way, in fact, and we don't fully understand what it is. Astronomers call it the Great Attractor. Discovered in the late 20th century, this mysterious region of space exerts a gravitational pull so strong it's drawing in not just our galaxy, but entire clusters of galaxies. We are moving toward it at a staggering speed of over 600 kilometers per second. That's more than 1.3 million miles per hour. And yet, we can't see it. This isn't science fiction. The reason we can't observe it directly is because it lies behind the dense center of our own galaxy, in a region called the Zone of Avoidance, a part of the sky so filled with stars, gas, and dust that our telescopes struggle to see through it. It's like trying to peer through a thick curtain of light. But what we do know is this: something massive and powerful is there, possibly a vast supercluster of galaxies, dark matter, or something we haven't even theorized yet. Some scientists speculate that it might be part of an even larger structure known as the Laniakea supercluster, the immense galactic web we belong to. The Great Attractor isn't just a name, it's a mystery, a reminder that even now, with our most advanced telescopes and data from missions like Hubble and the James Webb Space Telescope, there are regions of space cloaked in shadow, hiding secrets we've yet to uncover. It invites us to wonder, what else is out there beyond what we can see? What force could move galaxies like leaves on a cosmic river? Let's keep exploring. The next destination takes us deeper into the unknown. Stars can be older than the universe, or so it seems. Time in the universe is usually simple. The Big Bang happened and everything came after. But in 2013, astronomers found something strange, a star so old it seemed to have formed before the universe itself began. The star is called HD 140283, but many refer to it as the Methuselah star, named after the oldest person in the Bible. It's located just 190 light-years from Earth, practically next door on a galactic scale, and according to early estimates, it was over 14.5 billion years old. The problem? The universe is only about 13.8 billion years old. How can something be older than the thing that created it? Astronomers were puzzled. Some thought the age estimate was wrong. Others suspected there were gaps in our models of stellar evolution, the physics of how stars live and age. Still others believed it might offer clues to earlier versions of the universe, or physics we don't yet understand. Eventually, with more precise measurements from missions like Gaia, the estimated age of the star was revised slightly downward, but it still remains one of the oldest known stars, formed when the universe was barely born, and the mystery remains compelling. A star older than time, or at least older than what we thought time allowed. It's a reminder that the universe still holds paradoxes, that even with our best tools, there are things that seem to whisper, "You don't know me yet." As you drift off tonight, imagine a single ancient star, quietly shining for longer than it should, like a memory the universe forgot to erase. There might be planets made entirely of ice that's on fire. Imagine a planet far from any sun, drifting in deep space. Its surface is made of solid ice, but the temperature is over 1,000 degrees. How can that be? Astronomers believe some exoplanets, especially the so-called super-Earths, may be composed mostly of water. But under extreme pressure, water behaves differently. It doesn't melt. It becomes a form of superionic ice, a bizarre black, ultra-dense version of ice, where hydrogen atoms move freely through a lattice of oxygen. It's not only solid at extreme temperatures, it can even conduct electricity like a metal. Above this exotic core, the atmosphere may be made of superheated hydrogen and helium, creating temperatures high enough to melt steel. But deep below that fiery blanket, the crushing pressure keeps the ice frozen solid. It's one of the most beautiful contradictions in the universe. Ice that burns, fire that cannot melt. This isn't theory alone. Scientists believe planets like Uranus and Neptune might have similar layers of exotic ice deep beneath their clouds. But in more extreme exoplanets, with greater mass and heat, the effect would be amplified to cosmic levels. Planets like these challenge our instincts. On Earth, heat melts ice. But out there, in the pressure of alien worlds, opposites can coexist. As you close your eyes tonight, imagine standing on such a world, beneath a sky that burns, on ground that crackles like frozen glass. It shouldn't exist, and yet it might. The hell planet where it rains glass. Imagine a world where the skies are cobalt blue and winds scream at 5,000 miles per hour. A place where rain doesn't fall gently, but lashes sideways, made of glass. Astronomers call this type of world a hot Jupiter, a gas giant that orbits so close to its star it completes a full year in just a couple of Earth days. Temperatures on this planet soar to over 1,000 degrees Celsius, enough to vaporize silicate particles into the atmosphere. And as the planet cools on the night side, these particles condense and fall as sharp glass rain, slicing through the sky in winds faster than a speeding bullet. We don't have to name the planet. Its nickname, the Hell Planet, speaks loud enough. But the discovery of this alien weather system stunned scientists. It showed that even weather, something we think of as ordinary and earthbound, can turn into something entirely alien under cosmic conditions. This extreme world became a case study for exoplanets, planets outside our solar system, and helped scientists understand the wild diversity of alien worlds. It also sparked renewed interest in the tools we use to study them, from the Hubble Space Telescope to the new James Webb and future observatories designed by NASA and ESA. It's not science fiction, it's science fact. And it reminds us that in the vast universe, weather can be made of glass, and storms can tear the sky apart with no regard for life. So next time it rains where you are, remember, somewhere out there, the rain is deadly. The giant cosmic voids, where nothing lives. In a universe filled with trillions of stars, swirling galaxies, and glowing nebulae, there are also places of almost nothing. Vast, dark deserts in space, known as cosmic voids. Imagine a region so large it could swallow hundreds of Milky Ways, yet so empty it contains barely a few galaxies scattered like dust. These voids aren't just black, they're eerily silent, ancient, and uncharted. The largest, called the Buddha's Void, is over 300 million light years wide. If a spaceship traveled through it at the speed of light, it would see almost nothing for hundreds of millions of years. But how did these voids form? Scientists believe they are the result of cosmic inflation, the ultra-fast expansion of space right after the Big Bang. Matter clumped together into galaxies, pulled by gravity, while other regions were left behind, empty, silent, forgotten. They're not completely vacant. Sometimes a lonely galaxy drifts through the center, like a boat in a black ocean. But the scale of emptiness is staggering. No stars, no planets, no light, just the haunting hum of the cosmic microwave background, the echo of creation itself. Cosmic voids aren't just eerie, they might hold clues about the fate of the universe. Some theories suggest dark energy is expanding these voids, accelerating the universe's growth toward a cold, dark end, the so-called Big Rip. These invisible giants show us that space is not always filled with wonder. Sometimes, it's the absence that stirs the imagination most. So tonight, as you close your eyes, imagine drifting into the Bodis void, where silence is infinite and the stars are only a memory. Io, the most volcanically active body in the solar system. Beneath Jupiter's glowing bands orbits a tortured world, Io, one of its many moons. But Io isn't just another cold rock drifting through space. It's alive, violently, constantly, unimaginably alive. Imagine standing on a surface that quakes and shifts beneath your feet, not from tectonic plates, but from oceans of molten rock churning below. Now imagine volcanoes, not one or two, but hundreds, erupting constantly, hurling sulfur hundreds of kilometers into the sky. Some eruptions on Io shoot higher than Mount Everest is tall. What makes Io so wild? It's trapped in a gravitational tug-of-war between Jupiter and two other moons, Europa and Ganymede. As it orbits, these forces stretch and squeeze Io like a rubber ball, generating enormous heat through friction deep inside. That heat melts rock into lava, powering continuous volcanic fury. Io is painted in toxic yellows, reds, and blacks, colored by the chemical chaos on its surface. It smells, not that anyone's been there, like rotten eggs. A hellscape, but not of fire and brimstone, of sulfur and plasma. Scientists believe studying Io may help us understand how energy and motion shape worlds, not just here, but in distant exoplanet systems. It's also a reminder that moons can be just as fascinating as planets, maybe even more so. Carl Sagan once said that we are a way for the cosmos to know itself. Looking at Io, it feels like the cosmos is raging, shaking, boiling, exploding, just to make sure we know it's there. So while Earth's volcanoes sleep and stir, on Io, the ground never rests. The loneliest galaxy in the universe. Far beyond the glittering arms of the Milky Way, past galaxy clusters and cosmic filaments, lies a galaxy almost no one talks about. It's not because it's unremarkable, it's because it has no neighbors. Astronomers call it the loneliest galaxy, a spiral island adrift in the Black Sea of a cosmic void. While most galaxies live in bustling communities, swirling and merging with others, this one drifts in near total isolation, tens of millions of light years from the nearest galactic companion. Imagine living in a city, then waking up to find every other building gone. That's what this galaxy is, a cosmic orphan. Scientists believe it may have formed in an especially empty region after the Big Bang, where gravity failed to gather enough matter to create companions. And yet, it's thriving. This isolated galaxy forms stars, rotates gracefully, and glows with quiet resilience. It proves that even in the deepest solitude, a galaxy can shine. Its discovery challenged assumptions about how structure forms in the universe. If galaxies need interaction to grow, how does this one evolve on its own? It's a mystery that continues to puzzle researchers at NASA, ESA, and observatories around the world. Some scientists even speculate that such isolation could protect galaxies from cosmic threats, like gamma ray bursts or galactic collisions. In a way, solitude might be survival. It's easy to think of space as crowded with stars and life, but this galaxy reminds us the universe is also filled with distance, with silence, and with quiet, enduring beauty. So if you've ever felt far away from everything, remember, out there in the dark, something else is alone too, and it's still shining. Galactic cannibalism, when galaxies eat their neighbors. It sounds like science fiction, but it's one of the most dramatic truths in the cosmos. Galaxies can eat each other. This cosmic phenomenon is known as galactic cannibalism. When two galaxies come close, gravity pulls them into a slow, spiraling dance. But this dance doesn't end in harmony. It ends in one galaxy, tearing the other apart. Massive galaxies like our Milky Way have devoured many smaller companions over billions of years. Their stars are scattered into long tidal streams, wrapping around the host like glowing ribbons. The evidence is written in the night sky. We're not a peaceful spiral, but a survivor of ancient cosmic violence. And it's not over. In about 4 billion years, the Milky Way will collide with its neighbor, the Andromeda Galaxy. From Earth, it will look like the night sky is blooming with new stars. The result won't be an explosion. It will be emerging, forming a giant elliptical galaxy astronomers have nicknamed Milkomeda. This process isn't rare. It's how many of the universe's grandest galaxies formed by absorbing others. Some even have multiple cores, relics of past conquests. Scientists study these mergers using simulations and telescopes like Hubble and James Webb, seeking to understand how galaxies grow, evolve, and survive. Galactic cannibalism reminds us that even at the grandest scales, change comes through collision. Nothing stays still. Nothing stays safe. Even entire galaxies are drawn together by invisible strings, destined to meet, to merge, and to become something new. So next time you look up at the stars, remember, the sky may seem calm, but the galaxies are still hungry. The wow signal, a message from the stars. It lasted just 72 seconds, a blip, a whisper in the static of space. But it was enough to make one astronomer write a single word in the margins of the printout. Wow. In 1977, a radio telescope at Ohio State University picked up an intense as narrowband signal coming from the constellation Sagittarius. It was so unusual, so precise, that some believed it could be the first message from an alien intelligence. The signal matched no known natural source. It wasn't a star, a planet, or a galaxy. It had the clean, deliberate frequency of something artificial. And then, it was gone. Never repeated, never explained. For decades, scientists and enthusiasts alike have tried to understand the wow signal. Was it a rare space phenomenon? A one-time burst from an unknown object? Or was it a beacon sent across the void by someone or something else? It's the kind of mystery that Carl Sagan might have loved. A perfect blend of science, wonder, and unanswered questions. It inspired projects like SETI, the search for extraterrestrial intelligence, and influenced science fiction films like Contact. Despite countless attempts, the signal has never returned. Some say that proves it was just a glitch. Others believe we simply weren't listening at the right time again. But what if it was real? What if, across the emptiness of the cosmic void, someone knocked once, and we missed the chance to answer? The wow signal remains one of astronomy's great mysteries, a moment when the universe may have spoken. And even now, set deep in radio silence, some telescopes are still listening, just in case it says something again. Hypervelocity stars, shot out of the galaxy. Most stars glide through space in quiet orbits, circling the centers of their galaxies. But some stars break the rules. Some are flung violently at incredible speeds, shot like bullets through the cosmos. These are hypervelocity stars. First discovered in 2005, hypervelocity stars travel so fast that they can escape the gravitational pull of the entire Milky Way. That means they're not just wandering, they're leaving home forever. But what could give a star that kind of speed? The leading theory involves our galaxy's central supermassive black hole. If a binary star system gets too close, the black hole can capture one star and sling the other away at over 1 million miles per hour. A cosmic slingshot, elegant, terrifying, and real. Some hypervelocity stars are headed into intergalactic space, doomed to drift alone in the black void for billions of years. Others may crash into distant galaxies, like celestial arrows fired across the universe. For scientists, these rogue stars are more than curiosities. They serve as probes, helping us map the shape and mass of the galaxy, and even test Einstein's theory of general relativity on cosmic scales. Hypervelocity stars also spark the imagination. Could planets survive around such stars? Could life, by some miracle, hitch a ride across the universe on a world bound to no sun? It's a reminder that not all stars are bound by gravity. Some escape. Some race into the dark, glowing defiantly as they go. So when you see a shooting star in the night sky, remember, somewhere out there, a real star is shooting too, and it will never come back. The hexagon on Saturn, nature's perfect storm. High above Saturn's North Pole, there's a storm unlike anything else in the solar system. A massive, 6-sided hurricane, large enough to swallow 4 Earths. A perfect geometric shape, spinning endlessly in the clouds of a gas giant. A natural hexagon. First captured in detail by NASA's Cassini spacecraft, the Saturn hexagon left scientists awestruck. How could such a precise, symmetrical form exist in nature, especially in a planet's atmosphere? Unlike hurricanes on Earth, which are chaotic and short-lived, the hexagon on Saturn is stable and persistent. It has existed for decades, maybe centuries. Winds inside the shape whip around at over 300 miles per hour, and yet the 6 sides hold their perfect angles, It's not an illusion, it's a real rotating feature formed by powerful atmospheric waves known as Rossby waves. But the most haunting detail, no one fully understands it. Even today, scientists run simulations trying to replicate it. Some can get something close, but nothing as stable or as elegant. To many, the Saturn hexagon feels like a cosmic symbol, nature reaching for geometry, order inside chaos. It reminds us of the hidden symmetries in the universe, from the spirals of galaxies to the patterns of snowflakes. And then there's the color. Sometimes the hexagon glows in eerie blues and golds, changing with Saturn's seasons, lit by the distant sun, a storm that pulses with rhythm, not rage. Stephen Hawking once said, "The universe is not only stranger than we imagine, it's stranger than we can imagine." The hexagon proves him right. So next time you think of storms, think beyond clouds and thunder. Somewhere, far away, a planet is drawing perfect shapes in its sky. A day that lasts longer than a year. On Venus, time plays strange tricks. If you stood on its surface, through the thick yellow clouds in the searing heat, and watched the sky, you'd notice something bizarre. The sun would rise, crawl slowly across the sky, and set. But by the time it finished that journey, an entire Venusian year would have passed. That's right. A day on Venus is longer than its year. It takes Venus about 243 Earth days to rotate once on its axis, but only 225 Earth days to orbit the Sun. But that's not the only strange thing. Venus spins backwards. If you could look down from above, you'd see it turning in the opposite direction of most planets, including Earth. Astronomers believe this might be the result of a massive ancient collision, a planetary impact that flipped its spin and set it into a slow, retrograde crawl. Because of this rotation, the Sun on Venus rises in the west and sets in the east. But the thick clouds, made of sulfuric acid, would block most of the light anyway. Beneath them, the surface bakes at over 450 degrees Celsius, hotter than Mercury, even though it's farther from the Sun. Venus fascinates scientists for another reason. It's often called Earth's twin, similar in size and composition. But something went terribly wrong there. A runaway greenhouse effect turned it into a choking, pressure-crushed inferno. Studying Venus might teach us about climate, atmosphere, and even our own planet's future. In the quiet of space, Venus spins slowly, silently, unnaturally. A world where time stretches and twists. So tonight, as your day winds down, think of Venus, where days outlast years and the sun never sets quite right. The star that refuses to fade. Most stars die once. They burn their fuel, collapse, and vanish into silence. But astronomers have discovered a star that doesn't. It keeps exploding, again and again, a stellar ghost that won't let go of its light. This star, located in a distant galaxy, was first seen going supernova, a brilliant Higgs final burst. But months later, it erupted again, then again, over 50 times, each flare as bright as the last. Scientists named it IPTF 14AHLS, but most simply call it the zombie star. It shouldn't exist. According to physics, A star can only go supernova once. After that, its core collapses into a neutron star or even a black hole, but this one seemed to reset itself. Some theories suggest it may have shed layers before each explosion, like peeling off parts of itself to survive a little longer. Others think it's a pair instability supernova, a rare, massive star that doesn't follow the usual rules. Or maybe it's something we haven't seen before, a cosmic outlier, a mystery in plain light. This strange star reminds us that space doesn't always obey the script. Even death in the universe isn't always final. Sometimes, a star lingers, refusing to vanish, glowing defiantly through time. As you close your eyes, imagine it out there still, pulsing softly in a dark corner of the sky, a light that refuses to rest. Stars born from collisions. We often think of stars as gentle things, glowing softly in the night sky, distant and eternal. But in the heart of the universe, stars can be born from violent cosmic collisions. When galaxies crash, and they do more often than you might expect, their gas clouds slam into each other at incredible speeds. The pressure ignites chains of stellar births, entire regions of newborn stars flaring to life at once. It's called a starburst, and it's one of the most beautiful consequences of chaos. Unlike stars that form slowly in quiet nebulae, starburst regions are crowded, hot, and intense. They produce massive stars, blue giants that burn bright and die young in dramatic supernovas. It's a brief but brilliant life, written in fire and gravity. Some of the most stunning images from the Hubble Space Telescope capture these starburst galaxies, spirals twisted by collisions, glowing with clusters of newborn light. In one frame, you can witness the past, the present, and the future of a galaxy all at once. Even the Milky Way has had its moments. When it eventually collides with Andromeda, scientists expect a new wave of starbirth to sweep across both galaxies, a cosmic renaissance after a celestial impact. And here's a twist. Our own sun may have been born in a crowded starburst nursery billions of years ago, its origins tied to some long-forgotten galactic drama. So while collisions sound destructive, in the cosmos, they're also creative. From wreckage comes radiance, from impact, illumination. As you drift toward sleep, remember, sometimes the most brilliant lights in the sky are born from the deepest collisions. The black hole that sings in B-flat. In the depths of a galaxy, 250 million light-years away, something is humming. Not with sound our ears can hear, but with ripples in space itself. A black hole, deep inside the Perseus cluster, is singing a note that has lasted for millions of years. In 2003, scientists using NASA's Chandra X-ray Observatory discovered subtle waves in the hot gas surrounding the black hole. These waves weren't random. They pulsed in rhythm, creating the deepest known note in the universe, a B-flat, 57 octaves below middle C. Far too low for human hearing, but unmistakable in the data. This note is caused by pressure waves, sound waves, moving through the superheated gas. The black hole isn't making noise like a voice or an instrument. It's pressing space itself into vibration. And because of the scale, That vibration becomes song. It's a cosmic reminder that sound can exist in space, not in a vacuum, but in gas and plasma, where waves can still travel. It also shows that black holes, often thought of as silent destroyers, can shape their environments in strange and beautiful ways. Some researchers call it a ghost song, a ripple from something ancient and invisible. Others see it as a clue to how energy moves through galactic clusters, helping regulate star formation. To us, it's poetry, a silent melody from a place we'll never reach, a low, eternal tone echoing through space, unnoticed by most, but always playing. As you drift toward sleep, imagine it, a sound too deep to hear, pulsing through the cosmos like a breath. The cosmic web, the skeleton of the universe. If you could step far enough back, far beyond our galaxy, past clusters and superclusters, you'd begin to see a pattern. Not chaos, not emptiness, but structure. A delicate lattice stretching across the universe. Scientists call it the cosmic web. It's made not of stars or planets, but of dark matter and gas, invisible threads that weave galaxies together like beads on a string. This vast web forms the true architecture of the cosmos, dense knots where galaxies cluster, and filaments that stretch for hundreds of millions of light years. Between them lie cosmic voids, immense regions of almost nothing. But the filaments, they carry everything: galaxies, black holes, dust, light. And beneath it all, gravity holds the strands in place. The same force that makes an apple fall also sculpts the shape of the universe. We didn't always know it was there. The cosmic web was revealed through deep space surveys and supercomputer simulations. Only recently have we begun to see the hidden framework, like lifting a veil on the bones of the cosmos. Some physicists believe this structure could help explain the behavior of dark energy. Others suggest that the cosmic web acts almost like a neural network, a vast, mindless brain pulsing with gravity and light. It's not consciousness, but it feels like thought. In the silence of deep space, where galaxies drift like lanterns, this web connects them all, a hidden pattern holding everything together. As you fall asleep, imagine floating through this structure, not lost, but woven into something vast and timeless. The interstellar object that flew through our solar system. In October 2017, astronomers detected something strange moving through the solar system. It was long and fast, tumbling as it passed the sun. And it wasn't from around here. It was the first confirmed interstellar object, a visitor from another star system. They named it Oumuamua, a Hawaiian word meaning scout or messenger from afar. And in a way, that's exactly what it was. Unlike any asteroid or comet we've seen before, Oumuamua didn't behave the way it should have. It had no visible tail, but still accelerated slightly, as if pushed by something other than gravity. It was shaped more like a cigar or a pancake than a rock, and its reddish color hinted at organic material on its surface. Some scientists proposed it was a fragment of a planet. Others thought it might be a strange type of comet with invisible gas. And yes, a few even wondered if it could be artificial. A spacecraft? A probe? Avi Loeb, a Harvard astronomer, famously suggested it might be alien technology, a possibility still debated today. What's certain is this: Oumuamua came from outside our solar system, and it left just as quickly. We saw it once, and now it's gone, racing back into the dark, never to return. It was a reminder that the space between stars isn't empty. Things move through it: objects, fragments, messengers, and maybe others. As you drift to sleep, imagine standing still while something ancient passes by, quiet, brief, unknowable, on its journey through the endless night. How time slows down near a black hole. Time doesn't tick the same for everyone, not in the universe, not near a black hole. According to Einstein's theory of general relativity, the stronger gravity is, the more it bends space and time. Near a black hole, where gravity is so intense that not even light can escape, time itself stretches. It slows. If you were to orbit close to a black hole, just outside its event horizon, minutes for you might equal years for someone far away. You wouldn't notice anything strange. Your heart would beat normally, your breath would be calm. But the universe around you would race ahead. Stars would age, galaxies would drift. And when you returned, you'd find that decades, even centuries, had passed. This is called time dilation, and it's not just theory. We've observed tiny versions of it here on Earth, in satellites and high-altitude flights. But near a black hole, it becomes extreme, almost poetic. In the film Interstellar, this concept became a key plot. A crew visits a planet near a black hole, and when they leave, they find that years have passed for those who stayed behind. That scene wasn't fiction. It was based on real physics, advised by physicist Kip Thorne, who later won the Nobel Prize for his work on gravitational waves. Black holes don't just bend space, they bend our sense of reality. They ask, what is time, really? And can it ever be trusted? As you close your eyes tonight, imagine time itself becoming soft, stretching like taffy at the edge of darkness. And somewhere out there, a clock ticks slowly while the stars rush by. White holes, theoretical twins of black holes. We know what a black hole is, a place where gravity pulls so hard that nothing, not even light, can escape. But what if there were something opposite? A place where nothing could enter, only escape. That's the idea behind a white hole, a hypothetical phenomenon predicted by the same math that gave us black holes. If black holes swallow everything, white holes spit everything out. Matter, energy, even time, flowing outward from a single point, like a film played in reverse. So far, no white hole has ever been observed. They remain a possibility, a beautiful one, on the edge of theory. But some physicists believe they might exist briefly in the quantum realm, or that dying black holes could transform into white holes, releasing everything they once consumed. Others take the idea even further, that white holes might be gateways. If black holes are entrances, maybe white holes are exits, openings into new universes. A wormhole connecting space and time like a tunnel through the fabric of reality. A wild theory, but not impossible. This isn't science fiction. Stephen Hawking, Roger Penrose, and other legendary minds have explored these ideas. They remind us that the universe doesn't just deal in what we see, it's also shaped by the mysteries we haven't solved yet. So tonight, as you close your eyes, imagine drifting toward the edge of a black hole and finding not darkness, but light spilling outward, a fountain in space erupting softly, a whisper from the other side. White holes may not be real, but in the quiet of sleep, the cosmos is still full of possible doors. The galaxy with a supermassive black hole that shouldn't exist. In the early universe, galaxies were small, chaotic, and just beginning to form. So when astronomers discovered a supermassive black hole inside a tiny ancient galaxy, they were stunned. This black hole was as massive as the one at the center of the Milky Way, but its host galaxy was just a fraction of the size. It shouldn't be there. According to everything we thought we knew, black holes grow with their galaxies slowly over time. But this one seemed to have grown too fast, or formed too early. The discovery raised deep questions. Can black holes form first, before galaxies? Could they shape their hosts instead of the other way around? Or is our understanding of cosmic evolution incomplete? This object, officially labeled J0313-1806, though we won't bother with names, lies over 13 billion light-years away. That means we're seeing it as it was when the universe was less than 1 billion years old. And yet, it already contains a black hole with over 1 billion solar masses. Some scientists now believe that in the early universe, primordial black holes may have formed directly from collapsing gas clouds, skipping the usual steps of star formation. If true, it would rewrite our timeline for how galaxies, and possibly life, could emerge. It's another cosmic paradox. Something so small, hosting something so vast. A reminder that the universe doesn't always follow its own rules. As you drift off tonight, imagine a tiny flicker of light in the early dark, a baby galaxy quietly carrying a heart heavier than anyone could explain. Tesla's dream of wireless energy from space. More than a century ago, Nikola Tesla dreamed of a world powered without wires, where electricity could be sent through the air, across continents, free and limitless. At the time, people called it impossible. But now, space agencies and scientists are turning his vision into something real. The idea? Space-based solar power. Giant satellites equipped with solar panels orbiting Earth, collecting sunlight 24/7, far above clouds, night, or weather. That energy would then be beamed down to the planet as focused microwaves or laser light and converted back into electricity on the ground. It sounds like science fiction, but engineers at NASA, JAXA, and even private companies are building prototypes. Some countries, like China, are already testing small-scale versions. The hope is to create clean, continuous power, not just for cities, but for isolated regions, disaster zones, even lunar bases. Tesla may not have lived to see it, but his dream echoes in orbit. Of course, challenges remain. How do you safely beam energy through the atmosphere? What if the transmission is blocked And how do you build and maintain structures the size of football fields in space? Still, the potential is vast, and the poetry of it is undeniable. The sun shining on satellites, sending power across the sky, lighting homes and hospitals below, all without a single wire. As you drift into sleep, imagine a future lit by starlight harvested above the clouds, a world where the hum of electricity begins in orbit. The dark flow. Something is pulling the universe in one direction. The universe is expanding, that much we know. Galaxies are drifting apart, carried by the stretching of space itself. But in 2008, scientists noticed something they couldn't explain. Clusters of galaxies, massive structures made of trillions of stars, were all drifting in the same direction, toward a mysterious point in the sky. Not just a few, hundreds of them, across billions of light years, as if something was pulling them. They called it the dark flow. This motion wasn't caused by gravity from anything we could see. Not a galaxy, not a cluster, not even dark matter. It came from beyond the edge of the observable universe, a place we cannot see or measure, a place outside our cosmic horizon. What could cause such a pull? Some scientists think it might be a region of space dense with mass, too far to detect. Others go further. Maybe it's another universe, a parallel reality, tugging at ours through hidden dimensions. The dark flow is still debated. Some researchers question the data. Others say it's real, one of the strongest hints that our universe is just one part of something larger. It's unsettling and awe-inspiring. For now, the dark flow remains a mystery, a silent drift, a quiet current drawing galaxies across the void, and we, small creatures on a tiny planet, are being pulled along too. As you fall asleep, imagine yourself floating on that current. No destination, no explanation, just motion, slow and eternal, toward the unknown. What happens at the edge of the universe? Does the universe have an edge, a boundary, a wall, or does it go on forever, stretching endlessly into the dark? It's one of the most haunting questions in cosmology, and one we still don't fully understand. The observable universe, everything we can see, has a limit. Light takes time to travel, and since the universe is about 13.8 billion years old, we can only see as far as light has had time to reach us. That makes a visible sphere around Earth, about 93 billion light years wide. But beyond that, it's unknown. Some theories suggest the universe is infinite. It has no edge, no center, just more galaxies and stars stretching without end. Others believe it's curved, like the surface of a balloon. So if you traveled far enough, you'd eventually return to where you started. And then there's the idea of multiverses, that beyond our universe lies not nothing, but other universes, bubbles of space-time, each with different laws of physics, each invisible to the others. If that's true, the edge of our universe might simply be the beginning of something else. What happens at the edge? We don't know. Maybe the fabric of space thins, maybe dimensions twist, or maybe it just continues. The James Webb Space Telescope is now peering farther than ever, studying ancient light from the universe's earliest moments. But even it can't see beyond the cosmic horizon. So tonight, as you fall asleep, imagine standing at the edge, not of a cliff, but of reality itself, staring into the unknown, not afraid, just curious. Because sometimes the biggest mystery isn't what we see, but what we can't. Signs of life on K218b. Imagine a world more than 120 light years away, circling a small red star in the constellation of Leo, a place not too hot, not too cold, a place where clouds drift through a hydrogen-rich sky, a place where oceans might cover the surface, deep, dark, and calm. This world is called K218b, and it's unlike anything we've seen before. In 2023, the James Webb Space Telescope turned its golden eyes toward this distant exoplanet. What it found was remarkable. Scientists discovered water vapor in its atmosphere, a sign that this world might host liquid water on its surface. But there was more: methane, carbon dioxide, and possibly something called dimethyl sulfide, a molecule that on Earth is produced only by life, specifically by tiny marine creatures in the ocean. No one is saying for certain that life exists there, but for the first time, we are looking not just at rocks and gas, but at biosignatures, chemical hints that something alive may be breathing in the dark. K2-18b is what scientists call a Haitian world, a planet with both a hydrogen atmosphere and a liquid ocean. It's more than twice the size of Earth, and its skies may shimmer in unfamiliar colors. The gravity is stronger, the pressure deeper, and yet, conditions there may be right for something to thrive. Something alien, something simple, something alive. Even now, light from that planet is still making its way toward us, each photon carrying a whisper of its atmosphere, a distant message wrapped in hydrogen and mystery. So tonight, as you close your eyes, know that somewhere far away, there may be a quiet ocean rippling in the light of a red sun, and perhaps beneath its waves, something stirs. Now, let's drift to another world, a place of violent beauty, where the wind howls and the rain cuts like glass. Let's journey to a planet of storms. Let's drift to a beautiful world, a real planet where glass rains sideways through roaring winds. The planet where it rains, glass sideways. Let's imagine a different kind of planet, not quiet, not calm, but beautiful in its own terrifying way. This is HD 189733b, a gas giant 64 light years away, locked in a tight orbit around a burning orange star. It's a deep blue world, the color of cobalt and ocean. But don't let the color fool you. This is not water, and it is not safe. Winds on this planet reach speeds of 5,400 miles per hour. That's faster than sound, faster than any storm on Earth could ever dream of. The sky is filled with vaporized glass, and when it rains, it doesn't fall gently. It slashes sideways. Imagine standing in a world where the sky shines blue with silicon particles, where shards of glass swirl through the wind like icy daggers in a hurricane. It's beautiful and deadly. The heat on the star-facing side of the planet reaches over 1,700 degrees Fahrenheit, hot enough to melt rock, while the night side is hundreds of degrees cooler. This contrast fuels violent atmospheric waves that whip around the planet in hours. There is no ground, no ocean, only endless clouds of storm and fire. We may never visit such a place, but we can observe it, measure its temperature, decode its colors, all from here on our little blue dot. It reminds us that the universe is not just peaceful, it is fierce, it is strange, and it is full of places that defy our imagination. Tonight, as you breathe slowly, imagine the storm in the distance. Let it roar far away from you. Let the wind howl on that world, while here everything is still. Let it pass, let it go, let it fade into the stars. Next, we leave the storms behind and visit a galaxy so massive it dwarfs the Milky Way 100 times over. Let's keep drifting. Let's return closer to home, to the giant that gathers moons like fireflies, Jupiter and its 95 moons. In our own solar system, there is a world so large that it bends the paths of other planets. This is Jupiter, the gas giant, a planet made almost entirely of clouds, storms, and endless wind. But beyond its swirling surface, there's something else that makes it unique. It has 95 moons. Some are no larger than mountains. Others, like Ganymede, are even bigger than the planet Mercury. Each moon is a world of its own. Volcanoes erupt on Io, icy crusts crack and shift on Europa, and beneath the surface, some of them may hide oceans, deep, salty, dark. Scientists wonder, could life exist there beneath the ice? In the movie Interstellar, a team of astronauts travels through a wormhole in search of habitable planets. And while the story is fiction, the setting, cold moons, distant gas giants, feels very real. Because in truth, some of our most promising targets for alien life aren't on distant stars. They're circling Jupiter. Its gravitational pull is so strong that it gathers and holds these moons like lanterns in a slow orbit, drifting in silence. And new ones are still being found. Every few years, telescopes spot another tiny companion, faint, far, tumbling through the dark. Imagine looking up into Jupiter's sky from the surface of one of its moons. You'd see the planet filling half the heavens, striped, stormy, spinning, a silent giant. Let the image stay with you. Let it slow your thoughts. Let your mind float through the cold light of 95 silent moons, from orbiting moons to spinning days. Let's drift next to a planet where time itself takes on a strange shape. Venus is waiting. From fierce winds to something even more massive, the largest galaxy ever found. Now, let's go bigger, much bigger. We live in a galaxy called the Milky Way. It's vast, home to over 100 billion stars, with spiral arms that stretch across 100,000 light years. It's hard to imagine anything larger, but it exists. Meet IC 1101, the largest known galaxy in the observable universe. It sits more than 1 billion light years from Earth, in the heart of a galaxy cluster called Abell 2029. and it is enormous. While our galaxy spans 100,000 light years, IC 1101 stretches nearly 6 million. That's 60 times wider. Its mass, at least 100 trillion stars. Some scientists believe it could contain over 100,000 Milky Ways inside its volume. But what's even more fascinating is how quiet it seems. No dramatic spiral arms, no colorful gas clouds, just a soft, glowing ellipse, a gentle swarm of old stars, fading slowly with age. Galaxies like this grow by merging, one collision after another, swallowing smaller galaxies over billions of years, a kind of slow cosmic cannibalism. And in its center likely sits a supermassive black hole, so vast it could swallow our entire solar system without even blinking. Lucy 1101 is ancient, tired, but vast beyond comprehension. It reminds us that even the largest things can be gentle, quiet, and fading with time. So as you float deeper into sleep, imagine drifting past it, a golden sea of stars, stretching endlessly into the dark. Up ahead, a planet closer to home, but with more moons than you can count. Let's wander toward the giant of our solar system. Now, imagine a place where a single day outlasts a year. Venus. Time turned inside out. Let's turn toward a planet that feels strangely familiar and yet completely upside down. Venus. It's Earth's twin in size, just a little smaller, orbiting the same star. But once you look closer, everything begins to twist. The clouds on Venus are thick with sulfuric acid. The surface is hot enough to melt lead, and the pressure would crush you instantly. But even more surprising is how time works there. On Venus, one day lasts longer than an entire year. It spins backward, slowly, in the opposite direction of most other planets. So slowly, in fact, that the sun rises in the west and sets in the east, and it takes 243 Earth days for Venus to complete just one rotation. While its full trip around the sun, its year, only takes 225 days. That means if you stood on the surface of Venus, somehow protected, you'd see the same side of the sky for weeks, months, before anything shifted. Time would feel stretched, heavy, still, and when the sun finally moved, it would do so in reverse. No other planet in our solar system behaves like this. It's a reminder that time, even here, is not always what we expect. So tonight, as your breath slows and your thoughts drift, imagine a sky that never changes. A world where a single day is a lifetime. A planet wrapped in clouds and frozen in time. Now let's leave the orbits behind and float into something deeper, a force that moves galaxies but can't be seen. Let's talk about the invisible. Let's go beyond planets now and into the invisible force that pulls the universe apart. The mystery of dark energy. We know that the universe is expanding. Galaxies are drifting apart. Stars, once close, grow more distant with every passing moment. But what's pushing everything away? The answer is something we can't see, can't touch, can't even fully explain. Scientists call it dark energy, and it may be the most powerful force in the cosmos. It's not gravity, it's not radiation, it's not anything you can feel, and yet it makes up about 70% of the universe. It's everywhere, woven into the fabric of space itself, as if the universe has tension, a quiet pressure that pushes outward from within. In the 1990s, astronomers discovered something strange. The universe isn't just expanding, it's expanding faster and faster. Instead of slowing down like a ball tossed into the air, it's accelerating, and no one knows exactly why. Dark energy is the name we give this mystery, a placeholder for something we don't yet understand, a force that may never stop pushing, never stop growing, never stop separating stars from stars. It means that distant galaxies will one day vanish from view, moving away faster than light can reach us. And long after we're gone, the sky may grow quieter, emptier, darker, and yet there's peace in that. The universe is not static. It breathes, it grows, it changes, just like us. So tonight, as you breathe slowly, imagine that quiet energy all around you. Not loud and not forceful, just present, soft, steady, silent. Next, let's travel back in time to the first light that ever existed. Let's drift toward the echo of the beginning. And what about the stars themselves? How they live and how they fade. The life and death of stars. Look up into the night sky, and you're looking into the past. Every star you see is a story already in progress. Stars are born, they shine, they burn, and then they die. It begins in giant clouds of gas and dust, silent nebulae floating in the dark. Gravity pulls everything inward, slowly, steadily, until the pressure is so great that fusion begins. A star is born. For billions of years, it shines, turning hydrogen into helium, releasing warmth, light, life. Some, like our sun, live gently. They glow steadily, never too hot, never too wild. They age slowly and eventually expand into red giants, their outer layers drifting off like petals in the wind. Others are massive, fierce, unstable. They live fast and end in fire, exploding in supernovas, so bright they can outshine entire galaxies for a moment. And what remains? Sometimes a neutron star, a core crushed into a single spinning point. Or if the star is heavy enough, it becomes a black hole, a place where even light can't escape. But nothing is wasted. The elements forged in that star, carbon, oxygen, iron, are scattered into space. Those same atoms may one day become planets, oceans, trees, people. Stars die and give life. And so the cycle continues, in silence, in fire, in time. So as you rest, remember that the light above you once came from chaos, and now it watches you sleep. Up next, we leave the stars behind and drift into something emptier, a place so strange It's almost impossible to describe. Let's enter the void. To understand where it all began, we must listen to the faintest echo, the cosmic microwave background. Long before stars were born, before planets formed, before galaxies took shape, there was light, faint, uniform, everywhere. This is the cosmic microwave background, a soft glow left over from the birth of the universe itself. It began with the Big Bang over 13.8 billion years ago. At that moment, the universe was dense, hot, and full of energy. As it expanded and cooled, the first atoms formed. And when they did, light was finally free to travel. That ancient light has been drifting through space ever since. It stretches and cools as the universe grows, until now, it exists as a quiet hum of microwaves, barely above absolute zero, and yet we can detect it. Satellites like COBE, DSMAP, and Planck have mapped this ancient radiation in stunning detail. What they see is a faint, rippling pattern, tiny temperature differences scattered across the sky like fingerprints. These ripples hold the memory of the very first moments of time. They tell us how matter clumped together, how galaxies formed, how the universe became what it is now. The light is everywhere, all around you. Even now, as you lie here listening, trillions of these ancient photons are passing through your body, harmless, invisible, timeless. It is the most distant thing we can see, and the oldest thing we've ever found. A whisper from the beginning, a lullaby from the dawn of everything. Let it surround you, let it quiet your thoughts. Let it remind you that even the oldest light can still shine. Next, we'll move from the beginning to the end. Let's visit a star in its final breath, a place where light is fading into silence. Now we float through emptiness, into the loneliest place in the cosmos, the supervoid. Not every part of the universe is filled with stars. Not every corner holds light. There are places so empty, so vast, so quiet, that even galaxies avoid them. They are called supervoids, regions of space stretching hundreds of millions of light years, almost completely devoid of matter. One of the largest is the Eridanus supervoid. It spans more than 1.8 billion light years across, and in that colossal space, there is almost nothing. No galaxies, no stars. Just the thin, faint presence of scattered atoms, drifting slowly through a darkness so deep it feels like silence itself. Scientists discovered it by studying the cosmic microwave background, that ancient light we talked about before. They noticed a cold spot, a place dimmer than expected, and behind it, this void. We don't fully understand how it formed. Some think it's a coincidence. Others believe it may hint at something more, even a break in the uniformity of space itself. But whether natural or not, it's there. A dark, hollow canyon in the fabric of the cosmos. A place so large, our own galaxy would be nothing more than a speck floating in its shadow. And yet, there's beauty in that emptiness, because in a universe filled with noise, with light, with gravity and heat, this is stillness, not absence, but pause. So breathe slowly. Let yourself drift into that vast, quiet hollow, a moment between stars, a place where even time may hold its breath. Now, let's return to the edge, to the farthest point we can see. Let's look toward the boundary of it all. What do astronauts eat in space? Let's float gently into orbit and open a small foil pouch labeled Space Chicken Teriyaki. That's right, this is dinner aboard the International Space Station. In the early days of spaceflight, astronauts squeezed pureed meals from aluminum tubes, like toothpaste, but filled with meat and vegetables. Yuri Gagarin, the first human in space, famously ate meat puree and chocolate sauce while orbiting Earth. It wasn't elegant, but it was revolutionary. Over the decades, NASA, Roscosmos, and now SpaceX and Blue Origin have worked to make space cuisine more palatable and even comforting. Today's astronauts enjoy a menu that includes pasta, beef stew, shrimp cocktail, oatmeal, and even cookies. Everything is carefully designed for life in microgravity. Why so much care? Because food in space isn't just about calories, it's about morale. A familiar taste can be a powerful emotional anchor when you're 400 kilometers above the Earth, floating in silence. Of course, crumbs are still the enemy. Even a tiny breadcrumb can clog a ventilation system or drift into a crew member's eye. That's why most food is vacuum sealed, freeze-dried, or thermostabilized. Water is added with a needle, and utensils are magnetic or velcroed to the tray. Salt and pepper? Only in liquid form. Powdered seasoning floats. Recently, astronauts have even started growing lettuce, radishes, and mustard greens aboard the ISS as part of research into sustainable space agriculture, a vital step if we ever want to live on Mars or explore deeper into the solar system. So yes, you can eat tortillas in space, and pudding, but not cake with candles. Each bite connects astronauts to Earth and to each other. In space, flavor is memory, and memory sometimes is the most important fuel. Why there's no up or down in space. Now that we've had a quiet moment to explore what astronauts eat, let's drift into something stranger, something we often take for granted until it disappears. Let go for just a moment. No seatbelt, no floor beneath your feet. You begin to drift, not forward, not backward, just drift. In space, direction loses meaning. There is no universal up or down. On Earth, we know which way is which because gravity pulls everything toward the center of the planet. But in orbit, that pull is gone, and so is the concept of orientation. Astronauts aboard the International Space Station often describe a strange sense of freedom and confusion. A wall becomes a ceiling, a window becomes a floor. Your body rotates without friction, without resistance, and your brain, conditioned by gravity since birth, has to unlearn everything it thought it knew. There are no ceilings inside the station, no floors either. Tools are clipped to the walls, or what looks like a wall, until someone else floats in upside down and casually calls it a desk. Even the way spaceships dock must account for the absence of verticality. Approaching modules align based on arbitrary markers, not gravitational logic. Inside, every workstation is designed to be accessed from any angle, because angles themselves are relative. This concept challenges us. It's not just a quirk of physics, it's a reminder of how much we rely on gravity to define reality. Once it's gone, so is the certainty of what's above or below. In space, you are simply between stars, turning slowly, not falling, not rising, just existing, everywhere at once. The first message ever sent from deep space. As we continue drifting, weightless and untethered, let's tune our ears to the silence and listen for the very first whisper that came from beyond our world. In 1977, NASA launched two small spacecraft, Voyager 1 and Voyager 2. Their mission was to explore the outer planets, but they were also carrying something more poetic, a golden record, a message from Earth. It was humanity's first deliberate attempt to speak into the cosmic dark. The record, designed by Carl Sagan and his team, was etched with sounds and greetings in 55 languages, music from around the world, and natural sounds like thunder, laughter, and heartbeats. There's even a recording of a kiss, all packed onto a golden disc and fastened to a spacecraft with diagrams explaining where and what we are. At the time, few believed it would ever be heard. The chance that an alien civilization would intercept the signal was almost non-existent, but it wasn't really about being heard. It was about sending something, anything, into the infinite unknown, about saying, "We were here." Both Voyager spacecraft are still traveling. In 2012, Voyager 1 became the first human-made object to enter interstellar space. It still transmits weak signals back to Earth. It still drifts beyond the edge of the solar system, beyond planets, beyond light pollution, carrying that fragile hello across the stars. If someone, somewhere, someday finds it, they'll hear our music, our voice, our pulse. A message sent not with the expectation of reply, but with the hope that someone is listening. And now, so are we, floating quietly in the dark, listening to what we once dared to say, and what the universe never said back. Where does Earth's atmosphere actually end? We've spoken into the void, but where exactly does that void begin? Let's glide closer to home for a moment and ask a surprisingly tricky question. Where does Earth end and space begin? You might think there's a simple answer. Maybe it's where the blue fades into black, or where gravity gives way, or where satellites start to orbit. But the truth is, no one can quite agree. The most commonly accepted boundary is called the Kármán line, sitting at an altitude of 100 kilometers, 62 miles above sea level. Cross that line and you're officially in space. It's the altitude used by the Fédération Aéronautique Internationale to award astronaut status. But NASA uses a different threshold, around 80 kilometers, 50 miles. This is where the agency considers the boundary to space for mission classification and astronaut wings. Then there are private spaceflight companies like Blue Origin, which fly suborbital missions that just barely cross that threshold, offering a few minutes of microgravity and a view of the curve of the Earth. Yet here's the catch. Earth's atmosphere doesn't end abruptly. It simply thins out and keeps thinning. There's no clean edge, no border checkpoint, just a fading presence of air. The uppermost layer, the exosphere, stretches thousands of kilometers into what we would normally call space. In fact, in 2019, scientists discovered that hydrogen atoms from Earth's exosphere extend all the way out to 400,000 kilometers, beyond the orbit of the Moon. Technically speaking, the Moon itself might still be brushing through the edge of Earth's air. This means that the concept of where space begins is not scientific, but practical, a human construct. So next time you look up and try to imagine where the sky ends, remember, the transition isn't a step, it's a blur, a liminal space where air forgets how to be air, and Earth quietly fades into the cosmos. Can you cry in space? We've drifted to the blurry edge of Earth's breath. But what happens when emotion follows us into orbit? Let's ask something simple, almost childlike. Can you cry in space? The answer is yes, but not the way you think. Tears in space don't fall. In microgravity, they cling to your eyes, forming shimmering jelly-like domes that wobble with every blink. Instead of rolling down your cheek, they grow outward until surface tension finally breaks and the bubble of salt water floats away, carrying a tiny piece of you with it. Astronauts have talked about this. Chris Hadfield, one of the most eloquent voices from orbit, described the strange discomfort of crying in zero gravity. It's not like on Earth, he said. The tears just stay there, and they sting. Crying in space isn't just emotional, it's mechanical. Without gravity to guide them, tears don't behave. They sting the eyes, they obscure vision, and they remind you in a very physical way that you're not home. But astronauts do cry, from joy, from awe, from loneliness. Floating in silence above the world can bring intense emotional release. Imagine looking down on the Earth, a soft blue marble turning slowly below you, and realizing how fragile it is and how far you've gone. Some say tears are useless in orbit. Others say they're more meaningful there than anywhere else. Even NASA has studied how microgravity affects emotion, stress, and hormonal responses. Long-duration missions, especially future flights to Mars, will rely heavily on mental resilience. Because out there in the deep black, you don't just miss your family, you miss gravity, and sometimes the simple relief of a tear falling down your cheek. So yes, you can cry in space, but your tears won't fall. They'll float, glimmering like small stars, drifting gently across your face until they vanish into the air. The hidden ocean inside Europa. After the sting of weightless tears, let's go deeper, not emotionally, but literally. Beneath layers of alien ice, somewhere far from the warmth of the sun, something stirs, and it might just be alive. Let's journey now to Europa, one of Jupiter's many moons. At first glance, it looks like a smooth, cracked shell, bright, icy, scarred by deep brown lines that stretch like veins across its surface. But what lies beneath that surface is what makes Europa extraordinary. Scientists believe that under its frozen crust, Europa hides a global ocean, a vast saltwater sea, possibly twice the volume of all the oceans on Earth combined. And this ocean is warm. Not because of the sun, it's too far away. Jupiter orbits 5 times farther from the sun than Earth. The warmth comes from tidal flexing. As Europa orbits Jupiter, it gets pulled and squeezed by the planet's gravity, generating internal heat through friction. That heat might keep the ocean liquid. And where there's liquid water, energy, and organic molecules, there's always the question, could there be life? NASA is taking that question seriously. The upcoming Europa Clipper mission, launching in the next few years, will conduct flybys to analyze the moon's surface, its magnetic field, and, hopefully, the faint plumes of water vapor that occasionally spray from cracks in the ice. These plumes could carry clues about what's hiding below. Europa has become one of the most promising locations in the solar system to search for alien life, not intelligent life, not cities, but perhaps microbes, something ancient, slow, swimming in darkness, never seeing the stars, but living nonetheless. So as we float through this cold corner of the cosmos, remember, oceans don't only belong to Earth. Some sleep in silence beneath the ice, waiting to be heard. Why rocket? Launches always happen near the equator. From oceans trapped beneath the ice, let's rise again, upward still fast, explosive. Let's talk about the roar beneath our feet. Let's talk about rockets. Have you ever wondered why most rocket launches take place near the equator? Why places like Cape Canaveral in Florida, Kourou in French Guiana, or even India's Sriharikota are chosen instead of, say, somewhere in Canada or Northern Europe? The answer lies not in politics, but in physics and in the invisible spin of the Earth. You see, our planet is constantly rotating, spinning once every 24 hours. But not all points on Earth move at the same speed. At the equator, you're moving the fastest, over 1,600 kilometers per hour, just from the Earth's rotation alone. That's free speed, momentum, a natural slingshot. When you launch a rocket eastward in the same direction as Earth's spin near the equator, you get a huge boost. The rocket doesn't have to generate all the speed by itself. It borrows from the planet. That's why NASA chose Florida and why ESA built its main spaceport in French Guiana. Launching from higher latitudes means spending more fuel to fight against gravity and inertia, and in spaceflight, fuel is everything. There's another reason too: safety. Equatorial launch sites often face open ocean to the east, which gives rockets a safe corridor in case of failure, no cities or people below. And now, with SpaceX and Blue Origin designing reusable rockets and planning interplanetary travel, launch location matters more than ever. The physics haven't changed, but the ambitions have. So next time you see a rocket rising into the blue, remember, it's not just aiming up. It's riding the spin of an entire planet, using Earth's momentum to escape Earth itself. How space smells, according to astronauts. After the thunder of launch fades and the engines grow silent, what's left is something you wouldn't expect: a smell. You can't breathe in space, of course, not without a suit. But when astronauts return from a spacewalk and re-enter the airlock, the scent clings to them. It seeps into the fabric of their suits, and when they remove their helmets, it's there, waiting. So, what does space smell like? Astronauts have compared it to burnt steak, hot metal, welding fumes, gunpowder, even ozone. It's a strange mix: metallic, smoky, bitter, sharp. Some call it seared metal with a hint of raspberries. Others say it reminds them of the electrical scent left after fireworks. This smell doesn't come from space itself, which is a vacuum, but from chemical reactions. When high-energy particles from the sun and cosmic radiation strike the outer layers of a spacecraft, they create volatile compounds. These compounds cling to the surface of the suit and release into the cabin when repressurization begins. In a way, it's the smell of atoms colliding with stardust, a silent signature of the cosmos, brought home in tiny, invisible fragments. NASA has even recreated the scent on Earth to help train astronauts for the sensory strangeness of life off-world. And a few adventurous perfumers have tried to bottle it, literally, for public curiosity. One such product cheekily branded itself Ode to Space. It's fascinating, isn't it? How even in the absence of air, we find ways to carry traces of the universe back with us. Not just data, not just rocks or photographs, but experiences, smells, sensations. So the next time someone tells you space is cold and empty, remember, it has a scent, and it smells like something ancient, burned, brilliant, and alive. The quietest room on Earth, and what it has to do with space. We've talked about how space smells, but what about how it sounds? To answer that, let's leave the stars for a moment and step into a room here on Earth. A room so quiet, so deeply silent that you can hear your own heartbeat, your blood moving, your bones shifting when you tilt your head. This place exists. It's called an anechoic chamber, and the quietest one is in Minnesota, inside a lab built by Orfield Laboratories. It holds the world record for silence, reaching -9 decibels. That's quieter than outer space. In space, sound doesn't travel because there's no air, no medium. If you screamed aboard the International Space Station without your suit, no one would hear you. The vacuum doesn't care. Anechoic chambers simulate this effect in a way we can experience. They're lined with thick foam wedges that absorb nearly 100% of sound. Step inside and you'll feel unsteady because there are no echoes. Your voice sounds unnatural. Your footsteps feel wrong. Some people can't stay inside for more than a few minutes. But for NASA, These chambers serve a purpose. Space agencies use them to test equipment, microphones, instruments, even astronauts' reactions to silence. Preparing the human mind for deep space missions isn't just about muscle and math. It's about mental adaptation to nothingness. Because silence in space is not just quiet, it's absolute. And when you float outside a spacecraft, tethered only by a cable, with the stars standing still around you, silence becomes not the absence of sound, but the sound of absence. It's no surprise that many astronauts say this is what truly marks the boundary between Earth and space. Not gravity, not oxygen, but silence. Why astronaut helmets lock from the back. And now, as we near the end of tonight's journey, let's look at something small, something practical, a tiny design detail that, like so much in space, hides a story. Have you ever noticed that astronaut helmets don't lock in the front? They don't snap under the chin like motorcycle helmets or bike gear. Instead, they seal from the back, locking into the suit with a smooth rotation or latch. But why? It's not about aesthetics. It's about survival and visibility. On Earth, helmet design prioritizes mobility and ease, but in orbit or on the moon, the stakes are higher. A suit is a miniature spacecraft. It provides oxygen, pressure, temperature control, and protection from solar radiation. Every joint, every seal, every hinge must be flawless. The front of the helmet is reserved for one thing: the view. A wide, bubble-like visor offers maximum visibility, not just forward, but to the sides and even slightly downward. There's no room for bulky locking mechanisms in the field of vision. Instead, the collar of the suit becomes the anchor. The helmet locks from the back using rings, latches, or twist seals. This design also allows astronauts to put the helmet on more easily, often with assistance, and to ensure that the airtight seal sits evenly around the neck ring. If the seal fails, even by a millimeter, the result could be fatal. Modern suits used by NASA, SpaceX, and upcoming Artemis missions all follow this logic. Back-locking helmets, pressurized layers, and redundant systems, all engineered not for style, but for that unforgiving vacuum just centimeters away. So the next time you see an astronaut turning their head slowly inside a glossy dome, know that every piece of that helmet is part of a story, one told in oxygen, in silence, and in the fragile promise that it will hold. What Alpha Centauri might really look like. Just over 4 light-years away, drifting in the southern sky, is a system called Alpha Centauri. From Earth, it looks like a single bright star. But it's not. It's 3 stars. 2 of them, Alpha Centauri A and B, orbit each other in a tight gravitational dance, exchanging heat and light in a kind of stellar slow motion. The third, a dim red dwarf named Proxima Centauri, drifts on the outskirts, small and quiet, but potentially the most important. That's because Proxima Centauri is home to at least 2 planets, one of which, Proxima b, lies in the habitable zone, a place, at least in theory, where liquid water could exist. where a sky might glow with two suns, where shadows cross in curves instead of lines. We don't know what Proxima b looks like. We've never seen it. It was discovered by watching how its star wobbled, the gravitational fingerprint of something circling nearby. No telescope has captured its surface, no probe has flown past, and yet it has already captured our imagination. Projects like Breakthrough Starshot are exploring ways to reach Alpha Centauri within our lifetime, using tiny spacecraft with light sails pushed by Earth-based lasers to a fraction of light speed. If that ever happens, we might finally see it, not in pixels, but in light, not as a question, but as a place. So as you close your eyes tonight, imagine this: a world orbiting a quiet red star 4 light years away, a second sky, a second chance, and perhaps a second home. How do space telescopes actually work? We just imagined a world orbiting another sun. But how do we know such places even exist? To answer that, we have to look not with our eyes, but with instruments built to extend them far beyond Earth. We have to talk about space telescopes. Unlike ground-based observatories, which peer up through our thick, shifting atmosphere, space telescopes float above the weather, above clouds, above distortion, above the haze of light that Earth can't help but create. They see more clearly, more deeply, and often in wavelengths of light our eyes can't perceive, like infrared, ultraviolet, and X-rays. But how do they actually work? Most space telescopes, including Hubble, Spitzer, and Chandra, use mirrors, not lenses. These mirrors collect and focus faint light from distant stars, galaxies, and nebulae. The larger the mirror, the more light it can gather, and the farther it can see. The process is delicate. Light enters the telescope's main aperture, strikes a curved mirror, and is directed toward a secondary mirror and then onto a detector, like a digital camera. But instead of snapshots, it collects long exposures over hours, sometimes days. Each photon that arrives has traveled for thousands or even billions of years. In some cases, what we're seeing is no longer there. We're observing light's memory. And space telescopes aren't just passive observers. They're built for specific missions. Some study black holes, others hunt for exoplanets, some map cosmic microwave background radiation, remnants of the Big Bang. Each one a tool designed to answer a single question or reveal one we hadn't thought to ask. When you see those brilliant, color-rich space photos, know this: they're not just pictures. They're stitched mosaics of filtered light, translated from data. They are paintings made from physics. So the next time you look up, remember, someone, somewhere, is already looking farther. And the sky is not just watching us back. It's telling a story we're still learning how to read. The truth about space debris and how much is really up there. The truth about space debris and how much is really up there. This is space debris, and it's more than just a mess. It's a growing problem. Since the dawn of the space age in 1957, humans have launched over 6,000 rockets and placed more than 15,000 satellites into orbit. Not all of them came back. Many died in place as some exploded, others collided, and every time they left behind fragments, sometimes just a flake of paint, sometimes an entire booster stage. Right now, there are an estimated 100 million pieces of debris orbiting Earth. Of those, about 34,000 are large enough to be tracked from the ground, traveling at speeds of over 27,000 kilometers per hour. At that velocity, even a bolt can punch a hole through a spacecraft. The International Space Station occasionally performs maneuvers to dodge incoming debris. And in 2009, 2 satellites actually collided, creating a cloud of fragments that still circles the planet today. Some pieces burn up in the atmosphere eventually, but many don't, especially those in geostationary orbit, over 35,000 kilometers above Earth, where they can remain for centuries. Agencies like NASA, ESA, and even private companies are now working on solutions. Harpoons, nets, drag sails, magnetic capture. The goal isn't just to clean the sky, it's to keep access to space safe for the future. Because space isn't endless when it comes to orbit. There's only so much room around one small planet. So as we fall asleep tonight, let's picture it. A silver thread around the world, not of stars, but of fragments. A man-made constellation, glimmering, spinning, forgotten, but still there. The astronaut who brought a piece of the moon home in his pocket. Sometimes, space isn't about the machinery, it's about the moments. And this one begins with dust, ancient, gray, and silent. In 1971, during the Apollo 15 mission, astronaut David Scott walked on the surface of the moon. It was his 3rd space flight, but his first chance to step onto another world. With him, a small rake, a camera, and a geologist's trained eye. Unlike earlier missions, Apollo 15 was designed for science. The astronauts spent longer on the surface, brought a lunar rover, and collected over 77 kilograms of moon rock and soil. But Scott wanted more than just numbers. He wanted something personal. In a quiet moment near the lunar module, he slipped a small rock, no bigger than a coin, into a zippered pocket in his suit's leg. Not to steal it, not to sell it, just to bring it home separately. He later gave it to his daughter, not as a souvenir, but as a way to connect her to something real, something timeless. NASA was strict about samples, and technically, the rock still belonged to the government, but no one reprimanded him. The gesture was too small, too human. Today, that tiny stone sits in a private collection, nestled among family photos and childhood art. It's a fragment of another world, touched by sunlight that never filtered through Earth's air. It reminds us that behind every mission patch and checklist is a person, someone who misses home, who worries, who hopes, someone who, when given the chance, picks up a rock and thinks of someone they love. The moon is far, but the people who walked on it, so they were never more human than in the moments like this one. What space weather actually is and why it matters. We check the weather before going outside, but there's another kind, silent, invisible, and it comes from the sun. It's called space weather, and it doesn't bring rain. It brings radiation, plasma, and magnetic storms. The sun is not calm. It seethes with energy. Every few days, it releases bursts of charged particles in an event called a solar flare. Sometimes, those particles are carried outward in massive waves, coronal mass ejections, or CMES. When these waves hit Earth's magnetic field, they can do incredible things. Sometimes, it's beautiful. The aurora borealis, northern lights, dancing across polar skies. The particles energize atoms in our atmosphere, painting the night in green and violet. But other times, the effects are more dangerous. Strong space weather can knock out satellites, disrupt GPS, interfere with radio signals, and even damage power grids on Earth. In 1989, a solar storm knocked out electricity across Quebec, plunging millions into darkness. And in 1859, the Carrington event, the most powerful solar storm on record, caused telegraph wires to spark, catch fire, and continue operating after being unplugged. Today, with our growing reliance on satellites for weather, banking, communications, even farming, space weather matters more than ever. That's why NASA, NOAA, and the European Space Agency monitor the sun constantly. Special satellites like SOHO and Parker Solar Probe watch for flares and measure the speed of solar wind. Sometimes we have hours, sometimes just minutes. There's no way to stop space weather, but we can prepare for it. And the more we explore beyond Earth, the more critical that preparation becomes. So next time you see a glowing aurora or use your phone's location, remember, the sun is always reaching out, and sometimes space sends storms. The dark side of the moon, why it's always hidden. Let's turn now to something familiar and mysterious. Something we've seen in the sky our entire lives, and yet we've only ever seen one face. The moon is Earth's constant companion. It spins, it orbits, but it does something unusual. It always shows us the same side. No matter when or where you look, that familiar pattern of craters and shadows never changes. So what's on the other side? The answer isn't magical, it's mechanical. The moon is tidally locked to Earth. That means its rotation and its orbit take the exact same amount of time, about 27.3 days. So for every full spin on its axis, the moon completes one lap around our planet. It's not that the far side never sees sunlight. It does. In fact, it gets just as much light as the near side. But from our perspective, we never get to see it unless we send a spacecraft. The far side is more rugged, with fewer seas and more craters. It's harsher, older, less familiar. In 2019, a Chinese lander, Chang'e 4, became the first mission to soft land on the far side, revealing photos of a world that had never been seen from the surface. For decades, People called it the dark side of the moon, not because it's unlit, but because it's unknown. And perhaps that's what made it so poetic. A face turned away, keeping its secrets just out of view. Now we know what's there, but the feeling remains. That sense that something is always hidden, just behind the curve. Not dangerous, not mythic, just quiet. What would happen if Earth stopped spinning? The stars above us drift slowly each night, but they don't move. We do. Earth is spinning, always has been. But what if it stopped? It's the kind of question a child might ask, or the kind you think about in silence just before sleep. So let's go there. Right now, Earth spins at about 1,670 kilometers per hour at the equator. You don't feel it, but it shapes everything, day and night, wind patterns, ocean currents, even the shape of the planet itself. If Earth were to stop suddenly, instantly, the results would be catastrophic. Everything not nailed down would keep moving at that same speed. Oceans would surge, cities would crumble, the atmosphere itself would keep rotating, triggering global devastation in the first moments. But let's imagine something gentler. Let's say Earth gradually stopped, slowed over millennia until it no longer rotated at all. A day would no longer be 24 hours. It would be a year long. One side of the planet would face the sun in eternal daylight, scorching and dry. The other side, locked in darkness, would freeze. Only a narrow ring of twilight between them might remain habitable. Earth's magnetic field would weaken or vanish, since it's powered by the motion of molten iron in the core, motion tied to rotation. Without it, we'd be exposed to cosmic radiation, changing life as we know it. Tectonic activity, weather patterns, even timekeeping would all collapse into something new. A still world. A world of halves, light and dark, heat and ice. Of course, none of this is happening. Earth's rotation is slowing, but by just milliseconds per century. Still, it's humbling to realize that everything we know, morning, night, seasons, rhythm, depends on a quiet, invisible spin. And if it ever stopped, the silence would be profound. The oldest object we've ever touched. Let's turn now from motion to memory, not the memory of a person, but of the universe itself, of something far older than Earth, the moon, or even the sun. We're talking about stardust, and the oldest object humanity has ever touched is made from it. In 1969, a meteorite crashed near Murchison, Australia. Scientists collected its fragments and brought them to labs around the world. Inside, they found something extraordinary: grains of dust older than the solar system. How do we know? These grains are called presolar grains, microscopic crystals formed in the atmospheres of ancient stars. When those stars died, they scattered their contents across space. Some of that dust drifted for billions of years until it was caught in the cloud that formed our sun and planets. But some grains never melted. They remained intact, trapped inside larger rocks, and eventually they fell to Earth. By analyzing the isotopic ratios inside the Murchison meteorite, scientists determined that some of these grains were over 7 billion years old, older than our sun by more than 2 billion years. They are the remains of stars that lived and died long before our planet ever formed. They have no names, no story, just age. They are time in solid form. You can hold one on the tip of your finger, though you'd need a microscope to see it. A speck that predates the solar system, the Earth, and all living things. We like to think we live in the present, but sometimes the past falls from the sky, and when it does, it carries silence. So as you drift toward sleep, imagine it. A grain of stardust, older than time as we know it, resting quietly in a museum drawer, or floating still somewhere in the dark. Why do planets have rings, and why some lost theirs? We've held stardust in our hands. Now let's turn to something grander, not small, but vast. Not ancient by age alone, but by presence. Let's talk about rings. The halos around planets, the ornaments of gas giants. Most people know that Saturn has rings, wide, bright, unmistakable. But Saturn isn't alone. Jupiter, Uranus, and Neptune have rings too, thinner, darker, harder to see, but there. Even a few asteroids have been spotted with faint rings, held loosely by gravity. So, where do these rings come from? Most are made of dust, ice, and fragments, the remains of moons that shattered, or debris that never became a moon in the first place. They orbit in balance, too close to form a stable satellite, too far to fall inward. Rings are temporary. They may look eternal, but they're constantly shifting, colliding, fading. Some may last millions of years. Others may vanish within a few thousand. In fact, Saturn's famous rings, stretching hundreds of thousands of kilometers, might be very young. Recent data suggests they formed only 100 million years ago, possibly from a moon that drifted too close and was torn apart. And they're disappearing. In fact, Saturn's famous rings, stretching hundreds of thousands of kilometers, might be very young. Recent data suggests they formed only 100 million years ago, possibly from a moon that drifted too close and was torn apart. And they're disappearing. NASA's Cassini mission observed that Saturn's rings are slowly being pulled into the planet by gravity, raining down as icy particles, a majestic system dissolving into the clouds. So why don't all planets have rings? Some lost them. Some never had the right mass or circumstances. Some might gain them again if a moon is destroyed or a comet breaks apart too close. Rings are beautiful, but fragile. So as you drift off tonight, picture them. Arcs of ice, spinning in silence, remnants of chaos drawn into order, and someday into nothing at all. The Voyager record, what's actually on it. Let's end this part of our journey the way we started, with a message sent into the dark. You may have heard of the Golden Record, a gold-plated copper disc launched aboard Voyager 1 and 2 in 1977. But what's actually on it? The record was the brainchild of a small team led by Carl Sagan. Their mission: to create a message from Earth in case the spacecraft were ever found by another civilization or by no one at all. The contents are both precise and poetic. First, there are 116 images encoded as analog signals showing life on Earth: landscapes, DNA structures, people eating, animals moving, diagrams of atoms, planets, and human anatomy. There's a spoken greeting in 55 languages, including Sumerian and a child's voice in English, saying, "Hello from the children of planet Earth." There's a 90-minute playlist of music from Bach, Beethoven, and Stravinsky to Senegalese percussion and traditional Japanese flute. There's even Chuck Berry's "Johnny B. Good," just in case. Also recorded, the brainwaves of a woman in love, captured as she thought about the wonder of connection and possibility. The cover of the record itself contains instructions like a cosmic decoder ring: how to play it, how to find Earth based on pulsars, and how to measure time based on the decay of radioactive hydrogen. It's both science and art, both map and message. Voyager 1 is now over 24 billion kilometers away, the farthest human-made object in existence. It drifts through interstellar space, alone, carrying a time capsule of who we were or hoped to be. And maybe one day, someone will find it. Or maybe not. But it doesn't matter. Sometimes, the most important part of a message is sending it at all. How Starship is changing spaceflight forever. And tonight, we begin not with galaxies or ancient light, but with something real, a machine, a promise, a rocket tall enough to cast a shadow on the future. High above the sands of Boca Chica, Texas, a towering silver spacecraft waits, gleaming, restless, alive with fuel and fire. This is Starship, the creation of SpaceX, the vision of Elon Musk, and perhaps the vessel that will carry us farther than any human has ever gone. At 120 meters, it's the tallest rocket ever built. But that's not why it matters. Starship is designed to be fully reusable, capable of launching, landing, refueling, and flying again. Not just once, but many times. Like an airplane, only bound for the moon, Mars, and whatever lies beyond. Every test flight is a mix of spectacle and science. Some end in brilliant fire, others in gentle landings. Each one brings us closer to a future where space isn't a rare destination, but a regular departure. Its massive cargo bay could one day carry space stations, habitats, or even the first seeds of a Martian colony. Its Raptor engines, fueled by methane and oxygen, were chosen with purpose, because one day we may make those fuels on Mars. NASA has already selected Starship as part of the Artemis Moon program. But the real mission goes farther, making spaceflight accessible, affordable, and maybe ordinary. So as you close your eyes tonight, imagine it lifting off, not just a rocket, but the first step across a sky we've only just begun to touch. Why satellites don't fall from the sky. Starship may soar, but not everything in orbit burns fuel or lights the sky. Let's turn now to something quieter, something that simply stays, suspended, spinning, silent. All around our planet, satellites drift at thousands of kilometers per hour. Weather satellites, communication systems, GPS, and deep space telescopes, some the size of buses, others no bigger than a shoebox. So, why don't they fall? The simple answer is they are falling constantly, but they're also moving forward fast enough that the Earth curves away beneath them as they fall. That balance between gravity and motion creates an endless arc, an orbit. Imagine tossing a baseball across a valley. Now imagine throwing it so fast that as it falls, the ground curves away perfectly beneath it, forever. That's how satellites stay aloft. Most satellites orbit between 200 and 35,000 kilometers above the surface. The closer they are, the faster they must move to maintain orbit. The International Space Station, for example, travels at over 28,000 kilometers per hour, circling Earth every 90 minutes. But orbits aren't eternal. Over time, especially in low Earth orbit, drag from the atmosphere, even the thin upper layers, can slow satellites down. Eventually, they fall, burning up in the atmosphere like shooting stars. This is why satellites have planned lifespans, and why deorbiting has become part of modern satellite design. Some, like SpaceX's Starlink satellites, are intentionally placed low so they naturally burn up at end of life, reducing space debris. Others, like NASA's deep space observatories, are sent far beyond Earth's pull, where they'll drift in silence long after we're gone. So next time you look up at the stars, know that hundreds, even thousands, of human-made objects are up there too, not flying, not floating, just falling perfectly. The rocket that blew itself apart on purpose. Some objects fall with grace, others fall with thunder. Let's pause over a strange kind of space mission, one that ended not with success or failure, but with destruction by design. In the early days of rocketry, not every launch was about reaching orbit. Some were about understanding what happens when things go wrong, on purpose. One of the most dramatic examples is a test conducted by NASA in the 1960s, the Little Joe 2 escape system trial. It wasn't meant to carry a satellite or land on the moon. It was meant to explode. NASA needed to prove that astronauts could survive if a rocket failed shortly after liftoff. The solution? Strap a mock-up of the Apollo capsule to the top of a booster, launch it high into the sky, and then blow the rocket apart mid-flight. The test worked. At the moment of simulated failure, the capsule's launch escape tower fired, blasting it safely away from the exploding rocket below. It parachuted gently to the ground. Mission success. Modern rockets still embrace this idea. SpaceX, for instance, deliberately destroyed one of its Crew Dragon capsules in 2020 during an in-flight abort test. The capsule was launched atop a Falcon 9, and midway through the flight, the booster was shut down on purpose. The capsule's escape engines fired, the rocket tumbled, and Crew Dragon splashed down safely in the ocean. The point? To fail safely, to make sure again and again that if the worst happens, humans survive. It's counterintuitive, even poetic. Some of our most important moments in spaceflight have come not from reaching the stars, but from falling apart the right way. In space, safety isn't always in the launch. Sometimes it's in the exit. The first woman in space, and the message she sent home. Some rockets explode to keep people safe. Others rise with quiet power, carrying not just machines, but voices that had never been heard in space before. Let's travel back to 1963 to a spacecraft called Vostok 6 and to a voice crackling softly through the radio. It belonged to Valentina Tereshkova, the first woman in space. She wasn't a test pilot. She wasn't military. She was a textile worker and a skydiver, chosen from over 400 applicants by the Soviet space program to take part in one of the boldest missions of the era. Her call sign was Chaika, seagull. For 3 days, she orbited the Earth alone, circling the planet 48 times, floating, speaking, observing. All the while, millions below had no idea whether the mission would succeed. And yet it did. She became not only the first woman in space, but the first civilian to leave the planet. Her presence shattered assumptions and set the stage for generations of women to follow. She sent messages back to Earth during her flight. One of them was simple. The sky is very dark. The Earth is blue. How wonderful it all is. Her mission was not without problems. A programming error nearly caused the capsule to fly into deep space. Tereshkova noticed, reported it, and the mistake was corrected. She didn't just survive the mission, she saved it. Since then, more than 70 women have flown in space, from engineers to scientists to commanders. But she was the first, and she did it alone. Sometimes space exploration isn't about technology or fuel or re-entry angles. Sometimes it's about the sound of one voice echoing through the void for the very first time. How SpaceX lands rockets on floating drone ships. From one orbiting pioneer to another kind of boldness. This time, not in who goes to space, but in how they get there and back. Let's zoom in on a scene at sea. A gray barge drifting in the Atlantic Ocean, uncrewed, silent, and on its deck, a glowing target. Miles above, a rocket booster is falling. It was part of a Falcon 9 launched by SpaceX minutes earlier. It has already done its job, lifted cargo, or perhaps a satellite, or even a crew high above Earth. But now it's coming home. This is one of SpaceX's most remarkable achievements, the ability to land rockets upright, gently, and reuse them, not on launch pads, but on autonomous drone ships floating in the middle of the ocean. The names of these ships are poetic. Of course, I Still Love You, just read the instructions. They drift into place with GPS, their decks steady despite the waves, and the booster, falling at supersonic speed, fires its engines in short bursts, slows itself down, aligns, and touches down like a feather. All of this happens without human control. It's a ballet of code, precision timing, and atmospheric physics. Before SpaceX, rocket stages were single-use. They'd burn up or crash into the sea. Each mission required a brand new booster, costing tens or even hundreds of millions of dollars. Now, some Falcon 9 boosters have flown over a dozen times, reused, repaired, relaunched, again and again. Why land at sea? Because it's efficient. Rockets can launch heavier payloads if they don't have to turn around and return to land. The drone ships simply go where the rocket's arc ends, wait, and catch it. It's one of those moments where science fiction quietly becomes fact, not with noise, but with a soft landing on water. The sound of a black hole. What it really means. We've watched rockets fall back to ships. Now let's drift into something stranger, something that shouldn't make a sound at all. Let's talk about the moment a black hole was heard. In 2003, astronomers studying the Perseus galaxy cluster noticed something odd. Using NASA's Chandra X-ray Observatory, they detected ripples, faint pressure waves, moving through the gas that surrounds the central black hole of the cluster. Waves, like sound waves. Of course, sound doesn't travel through the vacuum of space, but in this case, the cluster was filled with extremely thin, superheated gas, enough of a medium to carry a vibration. The frequency, 57 octaves below middle C, a note 1,000,000 billion times deeper than human hearing. For years, it remained a scientific curiosity. But then in 2022, NASA did something unusual. They translated those waves into sound. They used real data to shift the frequency into an audible range, letting us hear the unhearable. The result was eerie, a deep, groaning hum, like wind echoing through a cave that shouldn't exist. It became known as the sound of a black hole. Of course, it's not a recording. It's a transformation, a scientific rendering of what space might sound like if our ears could stretch across galaxies. But that doesn't make it less real. It's still a voice rising from a place where even light cannot escape. And maybe that's the most poetic part, because for so long, black holes have represented silence, the end of sound, light, even time. But here, in this case, one of them spoke, softly, slowly, in the language of pressure and gravity, a song hidden in darkness and finally heard across the void. the spacesuit that costs more than a house. We've listened to the sound of a black hole. Now let's return to something closer, more familiar, something we've seen in every photo from space, yet hardly ever think about. Let's talk about the suit. To the untrained eye, a spacesuit might look like bulky clothing, part uniform, part protection, part tradition. But in reality, it's far more than that. It's a personal spaceship. Every modern extravehicular suit, the kind astronauts wear for spacewalks, is a miracle of engineering. It must keep the body alive in the vacuum, where temperatures can swing from minus 150 degrees Celsius to plus 120 degrees Celsius, where radiation is relentless and where the air doesn't exist. It provides oxygen, regulates temperature, monitors vital signs, and allows for controlled movement in zero gravity. It even contains its own communication systems and water-based cooling garments worn next to the skin. The cost? Roughly $150 million per unit. Yes, more than a luxury home, more than most small satellites. NASA's iconic EMU suits, used since the shuttle era, are decades old, but still in use on the International Space Station. However, they're reaching the end of their lifespan, and new suits are on the way. For the upcoming Artemis missions, NASA is working with private companies to develop next-generation suits. More agile, more adaptable, and tailored for the moon's surface, they must endure regolith dust, extreme temperature changes, and allow for longer exploration. One company, Axiom Space, is leading the charge, and the prototypes look more like science fiction than anything we've sent up before. But cost aside, the real value of a spacesuit is this. It allows a human to step into a place not meant for life and survive. So next time you see that glossy visor reflecting the stars, remember, behind it is a cathedral of systems, sensors, seals, and a fragile human heart floating quietly in the dark. Why Mars sunsets are blue. Let's pause now and imagine a sunset, not here on Earth, but on Mars. You might picture red skies turning orange, then deepening into twilight. But on the red planet, sunsets are blue, and the explanation is as strange as it is beautiful. Mars is famous for its rusty color, the result of iron oxide dust covering its surface. That same dust also fills the Martian sky. But unlike Earth, where particles scatter blue light, the fine dust on Mars scatters red light away, letting more blue light pass straight through. So as the sun sets on Mars, its fading rays travel through a thickening layer of dust. The blue wavelengths, usually scattered in all directions here on Earth, are instead focused forward, directly toward the viewer. The result? A glowing steel blue halo around the sun as it sinks toward the Martian horizon. NASA's Curiosity and Spirit rovers have captured these otherworldly moments in photographs, and they're haunting. The landscape glows in reds and browns, but the sky turns quiet, cold, and blue. It's the opposite of what we know, a reversal of expectation, a reminder that even something as universal as a sunset is shaped by where you stand or where you drift. Blue sunsets on Mars last longer than Earth's too. The thinner atmosphere means the light bends and scatters slowly. It gives the illusion that time is stretching, that dusk is lingering, holding on. And when humans finally walk on Mars, they'll end their days in that soft cobalt twilight, standing under a dusty sky, watching the sun set into silence. So as your own eyes grow heavy tonight, imagine that final light, a blue that lives on a red world, a quiet farewell from a planet that waits. The forgotten moon missions that almost happened. Mars may offer blue sunsets, but before we ever dreamed of that sky, all eyes were on the moon. We remember Apollo 11, of course, Neil Armstrong, Buzz Aldrin, the first human steps. But fewer people know that NASA once planned to return again and again. In the original Apollo program, there weren't just 1 or 2 missions. There were plans for as many as 20. Only 17 were officially numbered, and only 6 landed on the moon. After Apollo 17 in 1972, the program ended. But what came next, or rather what almost came next, is a story of canceled momentum. Apollo 18, 19, and 20 were all planned. They had designated crews, hardware under construction, and landing sites selected, including stunning regions like Tycho Crater and the Copernicus Highlands. These were areas with complex geology that could have rewritten what we know about the moon's formation. But by the early 70s, public interest had waned. Budgets tightened. The Vietnam War demanded resources, and some in Washington wondered, why go again? Haven't we already been? So the missions were quietly scrapped. Saturn V rockets were reassigned or turned into museum pieces. The astronauts assigned to fly them never launched. It's strange to think how close we came, how many dusty footprints could have existed, how much moon rock could have been brought home, how much science and wonder was left on the table. Today, the Artemis program is promising a return with modern spacecraft, new technology, and perhaps, this time, permanence. But in the silence between Apollo and Artemis, 3 ghosts remain, missions that never launched, but still orbit the edge of memory. And maybe one day, their names will be used again, picked up, dusted off, and finished. How the space race sparked microwave ovens. We end this journey not with rockets or planets, but with something humming quietly in your kitchen. A machine so ordinary you barely think about it, but it exists, in part, because of space exploration. The microwave oven. Its origin story begins with radar. During World War II, scientists discovered that high-frequency electromagnetic waves, microwaves, could be used to detect enemy aircraft. These systems grew more powerful and precise during the early Cold War, and their development accelerated during the space race. Engineers working on radar and communication for early satellites noticed something unusual. Microwaves could heat objects quickly. One often told story involves a scientist walking near a radar test and realizing the chocolate bar in his pocket had melted. This led to the first microwave ovens in the late 1940s. They were huge, expensive, and mostly used by restaurants or military facilities. But as space tech advanced, components became smaller, more efficient, and affordable, just like in computers and communication. By the 1970s, microwaves had entered homes, and they've never left. This is one of many space-age spin-offs, technologies created or refined in the pursuit of space travel that ended up changing daily life. Memory foam, cordless tools, freeze-dried food, even water purification systems, all of them trace back to space research. It's a reminder that space isn't just distant. It's here, in your home, in your phone, in your shoes, in every beep, every reheat, every late-night snack. So as you wind down tonight, think about this. Space exploration isn't always about the stars. Sometimes it's about the things that quietly orbit your life, unseen, but born from the same dreams. How the space race sparked microwave ovens. We end this journey not with stars or planets, but with something humming quietly in the corner of your kitchen, a device you use without thinking, but one that exists, at least in part, because of space. The microwave oven. Its roots reach back to the 1940s, during the development of radar systems. While working on high-frequency equipment, an engineer named Percy Spencer noticed something strange. The chocolate bar in his pocket had melted while he stood near an active radar set. Curious, he began experimenting, eventually placing popcorn kernels near the equipment. They popped. Next, he tried an egg. It exploded. Spencer had stumbled onto a new way of heating food using microwaves, a form of electromagnetic radiation. Early microwave ovens were huge, over 5 feet tall, and extremely expensive. They were mostly used in restaurants or on military bases. But things began to change in the 1950s and 60s when the space race pushed forward miniaturization, power efficiency, and advanced electronics. The demand for compact, high-frequency systems in satellites, telemetry, and communication relays led to technological breakthroughs, many of which filtered back down to Earth. By the 1970s, thanks in part to advances driven by NASA, the microwave oven became smaller, cheaper, and more accessible. It entered homes, offices, schools, becoming one of the most widespread spin-offs of the space age. And it's not alone. Other technologies born from or accelerated by space research include memory foam, freeze-dried food, infrared thermometers, scratch-resistant lenses, and even the humble cordless drill developed for use on the moon. When we imagine the legacy of space exploration, we often picture rovers and telescopes. But sometimes its influence is closer, heating soup at midnight or thawing leftovers after a long day. A quiet revolution hiding in plain sight. So as your thoughts drift into orbit, remember, the cosmos touches more than the sky. Sometimes it hums behind a kitchen door. Jupiter's most extreme storms, cyclones bigger than continents. Jupiter, the largest planet in our solar system, is a world of extremes. Its storms don't roll in gently, they roar. Most people know about the Great Red Spot, a massive storm larger than Earth, spinning for over 300 years. But that's just the beginning. Jupiter is wrapped in jet streams that blow in opposite directions, layered like ribbons around the planet. These bands create turbulence, and from that chaos rise cyclones, spinning vortices, many of them clustered around the planet's poles, each one larger than a continent. In 2016, NASA's Juno spacecraft flew over Jupiter's North Pole and revealed something astonishing. A perfect octagon of cyclones, 8 massive storms arranged in a ring with a 9th in the center. Each storm is over 4,000 kilometers wide, and they're stable, locked in place by invisible forces. At the South Pole, a hexagon of cyclones, patterns in chaos, weather drawn in geometry. But Jupiter doesn't just rage with wind, it glows. The planet produces auroras far stronger than anything on Earth, powered not by sunlight, but by radiation belts and magnetic forces so intense they could fry a spacecraft's electronics in seconds. It's a planet made not of rock, but of storm, clouds of hydrogen, rain made of helium droplets, and lightning that flashes 1,000 times more powerfully than anything on Earth. Yet from a distance, Jupiter seems calm, banded, striped, elegant. That's the paradox, beauty born of violence. And as you drift to sleep tonight, imagine it, a world wrapped in endless storms, a sky of spinning giants, and silence beneath the thunder. The mystic mountain where stars are still being born. Let's travel 7,500 light years away, not in distance, but in wonder. There, inside the Carina Nebula, floats a formation known as the Mystic Mountain, a vast pillar of gas and dust, rising 3 light years tall, sculpted by radiation, gravity, and time. It looks like a mountain, jagged, shadowed, towering. But it isn't solid. You could fly through it like smoke. This is a stellar nursery, a place where stars are born. Inside, gravity pulls gas together, squeezing it until atoms fuse and fusion ignites. A star is lit, but the birth isn't gentle. Newborn stars blast their surroundings with ultraviolet light and stellar winds, carving the cloud into shapes, peaks, pillars, and caverns. The mystic mountain is both being created and destroyed. Its beauty comes from the tension between formation and erosion, a moment caught between before and after. What we see today is already past. The light reaching us began its journey before the pyramids were built, before language had writing, before time as we know it was measured. We see it now, but the nebula has already changed. Inside the shadows are protostars, not yet stars, but on the edge. Some may never ignite, others will become suns. Each will have its own story, its own system, its own gravity. And in 1 billion years, one of those stars might have planets, and one of those planets might have someone looking back. So as you close your eyes tonight, think of the mystic mountain, a cloud sculpted by stars, hiding more stars inside, a place where light begins, in silence, in darkness, in dust, and where everything bright was once invisible. The Keyhole Nebula and the wild magnetic fields of Carina. Not far from the mystic mountain, within the vastness of the Carina Nebula, lies a darker, denser region known as the Keyhole. It's not a star, it's a shadow. The Keyhole Nebula is a small, cold pocket inside a storm of light, dense gas, thick dust, a silhouette inside brilliance. It looks like a dark bubble, but inside, invisible forces are at work. Because this region is threaded with magnetic fields, not just static lines, but twisting, curving, shifting strands of magnetic energy that shape how gas flows, how stars form, and how matter moves. These fields are not visible to the eye, but astronomers have mapped them using polarized light, detecting how dust grains align with magnetic currents. What they found is astonishing. The filaments bend, ripple, and sometimes twist into loops. They act like scaffolding guiding star birth, or like nets trapping gas until pressure bursts. This magnetic architecture is delicate, too weak to feel with your hands, but strong enough to shape solar systems. Inside the keyhole, stars are still forming, but not freely. They push against the invisible, and the invisible pushes back. We used to think of nebulae as clouds. Now we know they're living structures, not alive like us, but active, reactive, full of motion and memory. One day, this dark region will be torn apart by the stars it helped create. Its shape will vanish, but the stars it made will keep burning for billions of years. So as you fall asleep tonight, think of the keyhole, a dark room inside a brighter house, silent, magnetic, ancient, and full of stars we haven't seen yet. why there might be life inside gas giants. We often imagine alien life on rocky planets like Earth or Mars. But what if we've been looking in the wrong places? What if something lives inside the clouds? Let's talk about gas giants like Jupiter and Saturn, planets made mostly of hydrogen and helium with no solid surface, no ground to stand on, just endless atmosphere stretching for tens of thousands of kilometers. It sounds impossible, but maybe, just maybe, life doesn't need land. Some scientists believe that life could exist in the upper layers of these atmospheres. Not life like us, but floating organisms adapted to high pressure, low temperature, and chemical storms. They imagine microbial balloons, tiny sacs of gas that float, drift, rise, and fall on convection currents, feeding on sunlight, methane, or the rich soup of molecules found in these clouds. It's not fantasy. Here on Earth, we've found extremophiles, microbes that survive in boiling acid at the bottom of the ocean or inside nuclear reactors. If life can exist there, why not in a place like Jupiter? We already know that Jupiter's atmosphere contains organic compounds, lightning, cloud layers, and complex chemistry. It's dynamic, chaotic, alive with motion. Of course, we haven't found life there, and maybe we never will. But missions like JUICE and Dragonfly will soon explore other gas-rich worlds like Ganymede and Titan, searching for clues. And maybe one day we'll send a probe not to land, but to float, to dive into the clouds and listen for chemistry that whispers, "I'm here." So as you sleep tonight, imagine drifting through a golden sky and something drifting past you just for a moment. The Voyager probe that's now in interstellar space. In 1977, a small spacecraft was launched from Earth. It carried no crew, no return plan, just instruments and a golden record. Its name was Voyager 1. More than 4 decades later, it's still flying, still working, and now it's farther from Earth than any human-made object in history, over 24 billion kilometers away. Voyager has crossed a boundary few imagined it ever would. It has entered interstellar space. This means it has passed beyond the heliopause, the edge where the solar wind, the constant stream of particles from our sun, loses its power. Beyond this, the environment is shaped by forces from other stars. It is the space between solar systems. Out there, the temperatures are near absolute zero. Sunlight is a memory, weak, distant, nearly gone, but Voyager still moves forward, sending home data from instruments now older than most people alive today. It records cosmic rays, interstellar magnetic fields, plasma density. We are still learning from it, even now as it drifts silently through a sea of darkness. And inside the probe is a message. The golden record. It contains greetings in 55 languages, images of our planet, a baby's cry, the heartbeat of a young woman, songs of joy, sorrow, and everything in between, from Bach to Chuck Berry. It's a time capsule of humanity, not just what we are, but what we hoped someone might understand. One day its power will fail, the last signal will fall silent, but Voyager will continue on for millions of years, drifting among the stars, carrying our story. So tonight, as you close your eyes, imagine it. A spacecraft, alone in the dark, holding a whisper from Earth. Still going, still ours. How your body would change in zero gravity. Imagine waking up and there's no ups at all. In space, your body begins to change, not suddenly, but steadily, hour by hour, day by day. The most obvious change is height. Without gravity pulling down on your spine, the discs between your vertebrae expand. Astronauts can grow up to 5 centimeters taller, a gentle stretch that vanishes once they return to Earth. But that's just the beginning. With no gravity to pull blood downward, it redistributes. Faces puff up, legs slim down. It's called moon face, and it gives astronauts a round, flushed appearance. Nasal passages swell, voices sound stuffy. Even taste can change. Bones begin to weaken, losing calcium and density. Muscles shrink, especially in the legs and back. Even the heart changes shape, becoming more spherical, pumping in a new rhythm against a body that's no longer standing. Eyes can change too. Some astronauts experience blurred vision due to fluid pressure inside the skull. It's not always permanent, but it's still a mystery we're trying to understand. And then there's balance. On Earth, your inner ear helps you know which way is down. In microgravity, that signal fades. Astronauts often report a strange sensation, like their body isn't where it should be. It's called space adaptation syndrome, a quiet confusion of motion and orientation. But the most curious part? Eventually, this becomes normal. The brain rewires, muscles adjust, the body adapts, weightlessness becomes home. And when astronauts return to Earth, walking is difficult, standing feels heavy. The body must remember gravity again, slowly. So tonight, as you rest in bed, think of this. A body floating, shifting, learning a new way to exist, and proving, silently, that humans are made to adapt, even among the stars. The planet that rains iron. Some worlds are too strange to imagine and too real to ignore. Let's visit a place where the skies burn and it rains metal. This planet is called WASP 76b. It orbits a star about 640 light years away, and it's what scientists call a hot Jupiter, a gas giant roughly twice the size of our own, orbiting extremely close to its sun. How close? A year there's one full orbit takes less than 2 Earth days. And because it's tidally locked, one side always faces the star, and the other lives in permanent darkness. The day side reaches temperatures of over 2,400 degrees Celsius, hot enough to vaporize metals. On this side, iron turns to gas, rising into the upper atmosphere like steam from a boiling pot. But on the night side, temperatures drop drastically, and as the iron-rich air crosses from day to night, it cools and condenses and rains, not water, not ice, but droplets of molten iron falling through high-pressure clouds, hissing into denser layers below. We've never seen the rain directly, but astronomers using spectroscopy have detected iron vapor in the air and none on the night side. It disappears, it condenses, it falls. This isn't the only world like it. Other exoplanets may rain glass, sapphire, or silicates. But something about iron rain feels heavier, stranger, too violent to ignore, and too quiet to witness. So as you drift toward sleep, picture it. A planet scorched on one side, frozen on the other. A place where sunset brings not rest, but metals falling from the sky, and no one there to hear it. The silent collisions of ghost galaxies. We often think of collisions as violent, chaotic, loud, destructive. But in space, even destruction can be silent. Galaxies collide, not sometimes, not rarely, almost constantly. The universe is full of them, galaxies made of stars, gas, dust, and dark matter drifting through space at incredible speeds. And sometimes they meet. When two galaxies collide, their stars almost never touch. The space between stars is so vast, so empty, that even in a head-on crash, they pass through each other like ghosts. But the gravity remains. And that's where the transformation begins. Gas clouds compress, stars are thrown into new orbits, black holes spiral together, and in the chaos, new stars are born, sometimes thousands at once. Some galaxies are caught mid-collision right now. The antennae galaxies, NGC 2207, ARP 299, all tangled, stretched, glowing with newborn light. They look like torn silk in the sky. The Milky Way, our home, is on a collision course too. In about 4 billion years, it will merge with the Andromeda Galaxy. No explosion, no sound, just motion. A slow blending of stars over millions of years, forming a new, larger galaxy, Milkomeda. But not all galaxies are bright. Some are made mostly of dark matter, invisible to telescopes. And when these ghost galaxies collide, the stars don't shine. only gravity speaks. We detect them by the way they bend light, or how visible galaxies move around something we cannot see. So tonight, imagine this: two galaxies drifting through the void. No scream, no flame, no end, just the quiet folding of space and the birth of something new. The hottest exoplanet ever found. Some planets aren't just hot, they redefine what hot means. Let's drift toward a world called KELLT 9b. It's located about 670 light years from Earth, orbiting a blue-white star that blazes far hotter than our Sun. And KELT 9b doesn't orbit gently. It hugs its star so closely that a year, one full orbit, lasts just 36 hours. There is no sunrise or sunset, only day and night, each locked in place forever. The day side of KELT 9b reaches over 4,300 degrees Celsius, hotter than some stars. At these temperatures, molecules are torn apart. Even hydrogen struggles to remain whole. Iron, titanium, and other metals exist as vapor, stripped, scattered, and lost to the wind. And yes, this world has wind. Supersonic jets that sweep heat toward the night side, which is still glowing hot, but cooler by comparison. Even there, darkness doesn't bring relief. The planet is so hot that its atmosphere is evaporating, blown away into space, forming a long glowing tail, like a comet, but made of iron and heat. No surface, no clouds, no life, just energy. What's more, the star is young, and this planet might not survive it. In a few million years, KELT 9b could be gone, boiled away entirely, leaving only memory and data behind. We discovered it using the transit method, watching the star dim slightly as the planet passed in front of it. A blink from a burning world. So tonight, as you lie in the cool dark, think of this: a planet so close to fire, it glows. A world where night never truly falls, and where even atoms can't hold on. Could the universe loop back on itself? We often imagine space as endless, a straight line stretching forever in all directions. But what if it isn't? What if the universe loops? This is not science fiction. It's a real question in cosmology. And the truth is, we don't yet know the exact shape of the universe. There are three main possibilities. It could be flat, open, or closed. A flat universe extends forever, infinite without edges or curves. An open universe curves outward, like a saddle, expanding forever, but thinning as it goes. And a closed universe, so that's the one that loops. Imagine sailing in a straight line across the ocean and eventually arriving back where you started, without ever turning. In a closed universe, if you traveled far enough in one direction, you might return to your origin from the other side. It's like living on the surface of a sphere, but in 3 dimensions. There are no walls, no borders, just curvature so vast we can't detect it yet. Scientists look for clues in the cosmic microwave background, the ancient light left over from the Big Bang. They search for repeating patterns, like echoes, that could suggest space is folded. So far, the evidence leans toward flatness. But the universe is so large, we may only see a small patch of the whole. And maybe, just maybe, it wraps around in ways our minds struggle to grasp. So as you drift to sleep tonight, let your thoughts wander, not forward or backward, but around, because in a looping universe, every ending might just be a beginning in disguise. How Blue Origin plans to build in space. You've heard of SpaceX, of course, but there's another player, one that moves quieter but thinks just as big, Blue Origin. Founded by Jeff Bezos, Blue Origin's motto is Gratitium Ferociter, step by step, ferociously. Their vision goes far beyond launching satellites. They imagine a future where millions of people live and work in space, permanently. And they're building the tools to get there. Let's start with New Glenn, a reusable heavy-lift rocket named after astronaut John Glenn. It's massive, built to compete with Falcon Heavy, and designed to land vertically, just like its cousin, New Shepard. But Blue Origin's most ambitious project might be something called Orbital Reef. It's a planned space station designed like a mixed-use development, part science lab, part hotel, part business park. Imagine floating offices, research modules, and panoramic views of Earth, all coexisting in orbit. Blue Origin isn't doing it alone. They've partnered with Sierra Space, Boeing, and even Amazon Web Services to handle everything from propulsion to data transmission. The long-term goal? To shift heavy industry off Earth, to mine and manufacture in orbit, to protect the planet by removing the messiest parts of civilization from its surface. Bezos often compares this vision to the early days of computing, when machines were big, expensive, and rare. Space, he says, is on the verge of its mainframe to laptop moment. Will it happen soon? No. But the foundations are being poured, in vacuum, in silence above our heads. So tonight, as you fall asleep, imagine not just a rocket, but a blueprint, steel and glass, anchored in zero gravity, step by step, becoming real. The coldest place in the known universe. We often think of space as cold, and it is. But not all cold is the same. Let's drift now to a place so still, so empty, that it holds the title, the coldest place in the known universe. And surprisingly, it's not far from Earth in cosmic terms. It lies within a constellation called Bootes, about 5,000 light years away. There, Inside a large dying cloud of gas is a strange object with an even stranger name, the Boomerang Nebula. Astronomers discovered it in the 1990s while studying cold gas clouds using radio telescopes. What they found defied expectations, a cloud that appeared to absorb background radiation, not emit it. It was so cold, it seemed blacker than space itself. When they calculated the temperature, they were stunned. Just 1 degree above absolute zero, negative 272.15 degrees Celsius. That's colder than the background temperature of the universe. Colder than empty intergalactic voids. Colder than Pluto, Neptune, or the shadowed craters of the moon. But how is this possible? The Boomerang Nebula is formed by a dying star that's ejecting gas incredibly fast. As the gas expands, it cools, just like air from a spray can feel cold to the touch. Only here, the cooling is extreme because there's no atmosphere to slow it down, no nearby stars to warm it up. It's the universe's own deep freezer. Eventually, the nebula will warm up. The star will stabilize, and the gas will begin to glow. But for now, it floats in stillness, a ghost of a star wrapped in perfect chill. So as you settle under your blanket tonight, think of this place, a cloud colder than space itself, a breath of ice drifting through the dark. The Mars that used to be rivers, lakes, and lost air. Tonight, let's visit a place you think you know, the Red Planet. Cold, barren, lifeless, but it wasn't always this way. Once, Mars was blue. Billions of years ago, the planet had a thicker atmosphere protected by a magnetic field. Temperatures were warmer, and across its surface flowed rivers, carving valleys, feeding lakes, possibly even filling seas. We know this not by imagination, but by evidence. Orbiters have photographed ancient riverbeds, twisting channels that end in deltas, just like on Earth. Rovers like Curiosity and Perseverance have found rocks that only form in liquid water, clay minerals, rounded pebbles, salt deposits. Even craters once thought empty have turned out to be ancient lake beds. Places like Jezero Crater, where Perseverance is now searching for signs of past life. But what happened? At some point, Mars lost its magnetic field. Without it, solar wind stripped away the atmosphere. The air thinned, temperatures dropped, water evaporated or froze. Now only traces remain: ice under the surface, polar caps, and possibly briny underground lakes still hidden in the dark. The Mars we see today, dry, dusty, red, is not the Mars that was. It's a world that remembers water, but can no longer hold it. And yet, we're drawn to it, not just for what it could be, but for what it was. Because in every dry channel, every salt crystal, there's a whisper. I was alive once. I had clouds. I had rain. As we plan missions, rovers, and someday we're not just exploring Mars. We're trying to bring it back, to to understand how it changed and what that change says about us. So tonight, fall asleep under your own blue sky and dream of one that Mars once had too. The Saturn hexagon, a storm that shouldn't exist. Let's move now to the edge of mystery, to a shape spinning above a planet no one has ever walked on. Saturn, the second largest world in our solar system, is known for its rings, but high above its north pole, there's something else, a storm, and it's shaped like a hexagon. Yes, 6 sides, perfectly straight, perfectly stable, each side longer than Earth itself. A giant atmospheric vortex, first discovered by NASA's Voyager mission in the early 1980s, and it's still there today. Most storms form spirals, chaotic swirls, but this one is different. Why? Scientists believe it's caused by fluid dynamics, the result of jet streams interacting with the atmosphere at different speeds. In lab experiments, researchers recreated similar patterns by spinning liquids inside rotating cylinders. But Saturn's storm isn't small. It's 30,000 kilometers wide, deeper than Everest is tall, and spins at speeds of over 320 kilometers per hour. It has been raging for decades, possibly centuries, and no one knows exactly why it holds its shape. It pulses with colors: gold, blue, sometimes green, depending on the season. Cassini's close-up images revealed shadows, depth, and a swirling eye in the center, like a hurricane. But unlike hurricanes, it doesn't move. It simply spins in place, locked to the planet's rotation. There's no other known storm like it in the solar system. It's hypnotic, elegant, and slightly unsettling. Nature forming geometry at planetary scale. So as you drift into sleep, imagine standing far above the rings, looking down at a pole crowned with a hexagon, a 6-sided storm drawn in clouds, spinning forever in silence, a shape too perfect to ignore, and too strange to fully explain. How long could you survive in space without a suit? Let's imagine something unsettling. A person floating in space. No helmet, no suit, just the human body, exposed to the void. What happens, and how long would you survive? First, forget what you've seen in movies. You wouldn't instantly freeze. You wouldn't explode, but you also wouldn't last long. Space is a vacuum. There's no air, no pressure, and no way to breathe. The moment your helmet came off, the oxygen in your blood would begin to drop. You'd lose consciousness in about 15 seconds, not from pain, but from lack of air. You wouldn't suffocate in the usual sense. You'd simply black out. Your body would swell, but not explode. The skin is strong enough to hold it together. Saliva would boil on your tongue, not from heat, but from the lack of pressure. Tiny gas bubbles would form in your bloodstream. Your eyes would dry instantly. And after about 90 seconds, permanent brain damage would begin. If no one pulled you back in by the 2-minute mark, you'd die. But here's the strange part. It wouldn't be loud. It wouldn't be fiery. It would be quiet. No wind, no scream, just silence. Absolute and complete. NASA has tested vacuum exposure on animals and even humans during accidents in training chambers. In one case, a technician passed out and was safely revived after 25 seconds. He later said, "The last thing I remember was the moisture on my tongue starting to boil." So how long could you survive in space without a suit? About 60 to 90 seconds if someone finds you. And if not, you'd become one more silent satellite drifting slowly toward nothing. How we found a planet: by watching it blink. Not every discovery begins with noise. Some begin with the softest flicker, a tiny dimming in the light of a star, barely noticeable unless you're watching carefully. That's how we found our first exoplanets, not by seeing them directly, but by noticing when their stars seem to blink. This method is called the transit method, and it's beautifully simple. When a planet passes between its star and us, it blocks a small portion of the starlight. The dip in brightness is tiny, often less than 1%, but detectable, especially if the same dip happens again and again at predictable intervals. Each time the planet orbits, it creates a pattern, a signature, and from that flicker of light, we can calculate the planet's size, orbit, and even hints of its atmosphere. This method became powerful thanks to missions like Kepler, launched in 2009. Kepler stared at over 150,000 stars, capturing brightness data constantly. It didn't move, it just watched. And from that watching came thousands of discoveries. New worlds, some hot, some cold, some Earth-like, some entirely alien. The blink of a star told us that planets are everywhere, not rare, not distant, common ... Almost every star you see in the night sky may have its own solar system. We've since refined the method with missions like TESS and with ground-based observatories. We now even use it to study atmospheres as light filters through alien skies, revealing the chemical makeup of distant air. So next time you look up at a star, know this: it may have blinked once, and in that blink, it told us a secret. A planet, orbiting far from us, but not beyond our reach. His space hotel, what it could actually be like. Let's imagine something that sounds like science fiction, but is slowly becoming real. A space hotel, not a research station, not a rocket. A place to stay, to sleep, to wake up with Earth floating outside your window. Several companies have already proposed designs: rotating structures, orbital rings, inflatable habitats. Among them, Voyager Station, Bigelow Aerospace, and Blue Origin's orbital reef. Some plan luxury, others research. All of them imagine a future where space is not just visited, but lived in. So what would it be like? First, the view. Through reinforced dome-shaped windows, you'd see Earth turning silently. Sunrise and sunset every 90 minutes, the sky always black, even at noon. Inside, you'd feel weightless, unless artificial gravity was created by slow rotation using centrifugal force. You'd float between your beds and the dining area. Meals would come in sealed packages, not freeze-dried paste, but real food adapted for 0G. Showers? Not likely. Instead, air jets, warm towels, or sonic cleaning. Toilets? Well, they'd work by suction, not glamorous, but effective. There might be a gym, not to get fit, but to prevent muscle loss. On Earth, gravity works your body without effort. In orbit, you have to fight to stay strong. And then there's silence. Space is quiet. No birds, no cars, no wind. Just the hum of circulation fans, radios, and your own breath. Rooms might be small, sleep pods, fold-down bunks, but the experience, vast. The first guests will likely be researchers, scientists, or wealthy adventurers. But one day, space hotels may be as normal as airplanes once were, and staying in orbit could feel routine. So tonight, close your eyes and picture it. A room in the sky, and you floating, smiling, drifting gently to sleep between the stars. The stars that orbit nothing, rogue suns in the void. We often imagine stars in families, gathered in galaxies, arranged in spirals, held together by gravity. But not all stars stay home. Some are alone, not orbiting a center, not bound to a system, just drifting through the dark. These are rogue stars, sometimes called intergalactic wanderers. They travel between galaxies, alone and unanchored. How do they get there? Often it begins with violence. A collision between galaxies can fling stars outward like sparks from a grinding wheel. Or a supernova can kick a companion star free, a slingshot escape from a system that no longer holds it. Once unbound, the star moves in a straight line. No orbit, no sun, no home, just motion through intergalactic space. A place so empty, the next star might be millions of light years away. Some rogue stars are fast, very fast. Hypervelocity stars, shot from the center of galaxies after close encounters with black holes, can reach speeds of 2 million kilometers per hour. They leave their galaxies entirely, exiled but not destroyed, as others drift slowly, quietly. Old red dwarfs, burning dimly for billions of years, unnoticed in the void. We've found a few, but most we'll never see. They're too faint, too far. Their light doesn't reflect. Their stories go untold, and yet they exist, proof that not everything in the universe is part of a pattern. Some things just float. So tonight, as you settle in, remember, not all stars belong to a galaxy. Some wander, and in their wandering, they light a different kind of path, one that goes nowhere and everywhere at once. The rocket that turned around mid-flight and landed. For most of history, rockets were one-way machines. They lifted off, did their job, and fell back in pieces, in oceans, or in flames. But that changed. In 2015, something happened that looked impossible. A rocket launched, then turned around mid-flight and landed upright. The rocket was a Falcon 9 built by SpaceX. Its mission was to deliver a payload into orbit, which it did. But then, instead of burning up in the atmosphere, the booster flipped, slowed down, and began its descent. It passed through fire, re-entry burns, slowing its fall. It extended its landing legs, fired one last engine burst just above the ground, and landed, gently, like a pencil balancing on its eraser. It had left Earth and returned to it. This maneuver is called a propulsive landing. It's incredibly difficult. The rocket has to adjust for wind, speed, fuel limits, and target drift. The margin for error? Less than a parking space. It took multiple failures to get it right. Crashes, tumbles, explosions. But each time the data improved, and eventually it worked. Now landings have become routine. Falcon 9 boosters have flown more than a dozen times each, and new rockets like Starship are being designed to do the same, but bigger. Why does it matter? Because it makes space cheaper, cleaner, repeatable, like reusing an airplane instead of building a new one for every flight. But there's something poetic here too. A rocket that doesn't just leave, it comes home. So as you drift off tonight, imagine the fire and silence of that return. A machine built for escape, choosing instead to fall with precision, to land, to wait, to fly again. What it would feel like to walk on a gas giant. Let's end tonight's journey with a question that can't be answered by a mission or a probe, only by imagination. What would it feel like to walk on a gas giant? Planets like Jupiter and Saturn are massive, bigger than all the other planets combined. But they're not made of rock. They have no solid surface. So how could you walk there? Let's suppose you tried. First, your spacecraft descends through thick, endless clouds. At first, it's calm, pale bands of hydrogen and helium. You're floating, drifting. You pass through storms larger than Earth, including Jupiter's Great Red Spot, a hurricane that's been raging for centuries. As you go deeper, pressure builds. The light fades. Clouds turn to mist, then haze, then crushing fluid. There's no surface to land on, only layers. The gas thickens until it becomes liquid metallic hydrogen, a state of matter that doesn't exist on Earth. It would feel like diving into an ocean of lightning. The pressure here is immense, over 2 million times greater than Earth's surface. Your body, your ship, your thoughts would be compressed into silence. And below that, a core, maybe. Maybe not. We're still not sure. But one thing is certain. You wouldn't walk. You'd fall and fall and fall for hours, days maybe, until physics and time lost meaning. And yet, there's wonder in the imagining. Because even knowing you can't walk on Jupiter doesn't stop you from wondering what it would feel like if you could. So as your breath slows and your mind begins to drift, picture this: a descent through clouds no one has touched, a silence thicker than stone, and a step that never lands. At last, we reach the farthest edge, not of space, but of sight, the boundary of the observable universe. How far can we see? When we look into space, we're not just looking into distance, we're looking into time. The farther we gaze, the older the light, the deeper the view, and at some point, there's a limit. This is called the observable universe, a sphere surrounding us, about 93 billion light years wide. It's not the edge of everything. It's just the edge of what we can reach. What light has had time to bring us since the moment the universe began. Beyond that, more stars, more galaxies, or maybe something completely different. We don't know. We may never know. And strangely, there's no center either. Everywhere you stand in the universe feels like the center because space itself is stretching like dots on the surface of a balloon as it slowly expands. There is no edge you can touch, no wall you can press against, only a soft, moving boundary of vision shaped not by matter but by time. And that's the mystery. The farther we look, the more the universe hides. And yet, even from this small, quiet planet with limited eyes and fragile tools, we've seen so much. We've measured ancient light, heard the hum of the Big Bang, watched stars die and galaxies collide. And still, there's more. As you fall asleep tonight, know that there is no edge to thought, no boundary to imagination, and in that way, you too are infinite. Thank you for joining us on this journey. Sleep softly and keep drifting. The universe will be here when you wake up.